we will know more about the SEG user interface, the different modules available in SEG software, like the type of static equipment that we will deal with it, how to create a new project, how the different between the main elements and childs, like the difference between attachments like nozzles, the saddles, and the main elements like head, shell, cone, all of that. The user, the UCS, which is the user coordinate system, and how we can define the datum line and the reference for elements, how we can create unreal elements, and why we are using it, and the common mistakes and how we can deal with it. Okay, at the beginning we will start with the user interface. As you can see, we have a main tabs on the top of the SEG interface, which include the file, elements, simply edit, setting, and tables tabs. On the left hand side we have the tree view, and by the way, the tree view it's a drag and drop menu. You can move it anywhere inside the application interface, so you can move it on the left side or right hand side. So you can, by using the drag and move, you can move it from side to another side. The middle area, which is the main area, in this area you will be able to define the node which you are selecting. In case of selecting the project node from the tree, you can modify the project information. When you select the vessel node from the tree, you will be able to define the design data of the equipment. If you select any other node, like the head node or shell node, the information of this element will appear in this area. On the right hand side, you will find the tool box. This toolbox include the elements available on the nodes that you select, and we will check that during the demo, inshallah. On the bottom here, you will find the live chat button and the license period on the bottom left hand side. Here the tabs of available on SEG user interface. You can find on the file tab how to the button to generate a new project or open an old project, save as a current project, close this project, and some other buttons. On the element tab, you will find the main elements and the child elements. On the assembly tab, you will find the start assembly button and the stop assembly button. You will find the opening form, how to generate an opening for a nozzle on shell or head, creating a flat pattern, shell development for storage tanks, update item number, and we will talk in detail regarding those buttons. Edit tab, which include reset inventor model. You can use this button in case if you would like to reset all the model, delete all inventor items, and start creating your model from scratch, and some other editing features. The setting tab, you can control the equipment setting, like make it horizontal, vertical, and other options. The app setting, like making a rendering for elements during creation, controlling the configuration of nozzles if you would like to define it in DIN or in NBS, controlling the bill of material, creating the system files. This button, you will use it one time when you install SEG for the first time, or if you have a new release, you will check on this button after installing SEG to create the system files. And tables tab. In this tab you will be able to check the bill of material of your equipment, the nozzle table, and you will find many other tables. On the user interface, you will find a profile button. This profile button, you can define the user information like your name, your company, your email, and contact telephone. Those information will be used in case of using a report bug. If you would like to make or asking the technical team for an issue, you can send us an email. So the information which you used on the profile form, it will be used here to inform us about the user, so we can reply for him by using this contact email. You can change the skin of the software. You will find in the skin form a different type of skins. You can choose the suitable skin for the application to suit your needs. Here you will find on the file button a tutorial button. This tutorial button will show you the some tutorial videos on our channel, so you can check it directly inside the app, or you can open our YouTube channel directly to check the videos from on the browser. A template button. This template button, you will find some projects created by SEG Software, and you can check them to understand how you can generate the tree, how you can make a connection between elements, and different options. You will find it inside those pre-built projects. Here the different modules available in SEG Software. So you can make a horizontal pressure vessel. So in case of using this module, the default options for the position of the vessel will be a horizontal vessel. In case of using a vertical pressure vessel, the default option of the position will be defined to be a vertical vessel. In case of using a heat exchanger, some features which regarding the equipment heat exchanger will appear, like tube sheet, expansion joints, and tube bundle and the tube holding arrangement will appear in case of using heat exchanger module. The duct module, if you select duct feature, the duct module, the duct feature will appear on the elements. The same for storage tanks or spherical tanks or pipes. In case of using overall module, you will get all features of the SEG, like the feature of the pressure vessels, heat exchanger, ducts, storage tanks, or spherical tanks. The project data, we can define that the SEG tree include different levels. So the first level is the project level. Inside the project level, that's the project level, which is the first node. You can define the project information like project number, project name, plant name, client, all of that. And some of them will appear on the drawing, and you can control that and make those custom properties appear inside your title block. Like if you would like to define the manufacturer or the location or something like that, you can define it in your drawing, and we will discuss that how you can make your own border and your own title block to use it as a reference template, drawing template, and how you can make a link between those custom parameters inside your title block to make them as a dynamic and reading the information directly from this form. The second level is the equipment level. And inside the equipment level, you can define the design data of the equipment. When you select the equipment from SEG tree, you will be able to define the design data of the equipment, and we will discuss the different ways to define the design data. And you can import the design data from an external Excel sheet. On the same level, which is the equipment level, you can edit the vessel setting from the equipment setting. So you can change the position of the vessel by making it horizontal, tilted, or vertical vessel. You can change the direction of the assembly. You can make it start from left to right direction, or flip it to make it from left to right. That's in case of horizontal or tilted vessel. In case of making it a vertical vessel, you can start the arrangement from bottom to top, or you can flip it to make it from top to bottom. You will be able to define the surface of the equipment and the serial number of the equipment and the delivered blade dimensions. Those dimensions, SEG will use them to calculate the required circumference of the shell and the required number of blades on this shell. Like if you have a large diameter vessel, automatically SEG will calculate based on the delivered blade dimensions the required number of blades in this sheet. You can define the units of your project if you would like to define it in metric or in inch. And here's some of the main elements available in SEG, like head, shell, cone, flanges, body flanges, gaps, and many other types like gaskets or storage tank features like annular plates, radial roof, arranged or dome roof, a spherical tank end, or ducts feature. And here some attachments available for the main elements, like forehead, for example. You will find those attachments like skirt, support pipe or support beam, nozzles, couplings, or internal or external attachments. For shell, for example, you will find those type of supports like saddle, stacked saddle, tilted saddle, and some openings like those type of nozzles, other types of lifting lugs, external attachments, internal attachments. Here, the concept of the assembly in SEG, and that's very important to understand. SEG uses user coordinate system to assemble the items. Like if you have a flange, this basic, we will use it in all elements, all main elements. Like if you have a flange, for example, you will find a start UCS and the end UCS if you check the tree of the element inside Autodesk Inventor. So this user coordinate system, at the start of the element, we will use it to assemble this element to the previous element. And here we have, at the end, we have end UCS at the end of the element. So we will use this UCS to assemble this element with the next element. Okay, so you should know this concept during the assembly. SEG will make that automatically. No need to make it by hand, but actually you will need to understand this concept if you would like to make some modification by hand, so you can do that if you would like to make something like that. The attachment and how we can define the datum line. Here, if we have a nozzle connected to a shell, so the datum line of this nozzle will be related to the seam line or the start point of the main element. So when you define a location of a nozzle, so let's say we have this nozzle from 1 meter from this datum line, which is the seam line of this shell. So if you have a previous element like head, and this head includes a straight flange with 50 millimeters length. So when you defined the location of this nozzle in your mechanical calculation on 1 meter from the datum line, which is the tan line, not the seam line. So in SEG, to define the location of this nozzle, you will need to define it from the seam line. So you will need to calculate the required value from the seam line here, from the start point, not from the datum line in the calculation, which is the tan line, for example, in case of you have an ellipsoidal head or a head with a straight flange or another shell or something like that, because the datum line of this element defined it in SEG from the seam line or the start line of the main element, which is in this case, which is the shell. Another elements like gap and overlap, and we will use them inside our demo. You can make a gap between elements. In case of some companies make this gap to define it in the drawing, like if you have if you would like to make, let's say, 4 millimeters a gap between elements as a welding preparation, so you can use the gap option to define the gap between elements like that. So you will get a gap between the UCS of this element and the other UCS of this element. You can make an overlap, so you can check that we have this shell, and this shell include UCS at the end and UCS as a start. And if you would like to make a cone, but this cone will not start from the end of the shell, it's overlapped on the shell, so you can use this overlap element to come back with this UCS back here to start your cone from another point by using the overlap element. So the cone will not start from the end of the shell, it will start from the back distances that you defined it in the overlapped element. We will inshallah inside the demo we will use this option. We will learn inshallah how to make unreal elements, like in case of needing to make a nozzle attached to another nozzle, or making a coupling attached to a nozzle, how to make that by using unreal elements, and how we can add an element to a part not include a type of attachments. So those points we will discuss them during the demo inshallah. And we will talk about the common mistakes like modifying an element during saving, because this issue may cause a problem in your file, because your file or the SEG software, during sending commands to Autodesk Inventor, during this process, SEG come back with some information and record them inside the SEG file. So during writing in the SEG file, you make another process, so that may cause a problem. So how we can deal with that during running on Autodesk Inventor, how we can stop the assembly to make a saving for an element or something like that. Another issue, by selecting another node without checking the appearing form, and some other mistakes. So we will discuss those on the sample, on the demo. We will start from here. Here we have the SEG4, and as we discussed here, you have the profile button. You can define your information from this button, and those information will be used in case of using the report bug. If you would like to send a report to our technical support team, so the information here for the email or the telephone number will be used in your email. You can open tutorial videos when you click on this button and click refresh here. Some tutorial videos will appear here. You can select one of them to play it directly on SEG directly from here. And if you would like to open the channel, you can click on the YouTube button, and that will send you directly to our YouTube channel, so you can select the tutorial video from here and play it directly from here. Okay, some standard templates here. When you click on the templates, you will find some pre-built projects, so you can select a project from those and create it on a current location in your machine. After that, you can open it and run it and check the tree of this element and check how it's created, and you can learn from those pre-built projects. Here, when you install SEG for the first time, or if you have a new release, the first step you will need to make it before proceeding with creating a new project or opening an old project, you will need to create system files by checking on this button to create the files required to SEG. Now let's creating a new project by clicking on the new button. Here you will get this form, and from this form you will find the available modules here on SEG, like horizontal pressure vessel, vertical pressure vessel, heat exchanger, duct, tank, spherical tank, or piping. So from here, let's create our sample. And from here, let's create a new, select the location of the project. After that, let's select the module of the equipment and click on finish. Now SEG will start creating the project files. Here, if we come to the location, you will find this project file created here, which include an assembly folder, drawing folder, parts folder, and here the SEG file and the project file of the Autodesk Inventor. Okay, here let's select the project node, and when you select it from the tree, you will find those information of the project. If you would like to define them, you can define them, because some of them will be used on the title block. So it depends on what you would like to use. In case of needing to define those information to use them on the title block, so you will need to define them. If you will define that manually in your title block, so no need to spend time to define that here on SEG. So it depends on your requirements. In our case, let's define some information here, like the project name, like gas tank project, and name like that, name. The location like that. After that, you will click on save to save the information of this project. So here, if you select the equipment node and come back to the project, you will find the information is saved. Here, if you select the equipment node from the tree, you will be able to define the design data of this equipment. By the same way, if you have a special form for the design data, or it's not needed in your current equipment, so no need to fill it. But in case of needing to fill it, to reflect it in your drawing, you will need to fill this form by a different ways. Let's discuss them. Like the first way, by double clicking on the cell itself and modify the current value. Like if you would like to modify the minimum design metal temperature or the construction code, by clicking on this cell and redefine the value. The same here, like the construction code, you can define the value like that, or I make a refresh. The second way, by removing the checkbox which is defining the element here, so that row will not appear on the drawing or inside the design data in your drawing. So when you select it, it will appear, and in case of deselect it, it will not appear on the drawing. Another way to define that, by creating an Excel sheet. We have a pre-built Excel sheet here for the design data here. So you can read directly the Excel sheet from here, that we have this Excel sheet. So you can fill the data, and you should have 3 columns. So let's create a new one. Here from new, let's create a new Excel sheet, design data, and from here let's fill the data ourselves. So from here, let's fill the first cell, which is construction code, for example, VP 550. And the third row, you should fill it, don't make it empty. So we will add a dash, for example, like that. So here, design picture. And to make a degree, if you take a look to that one, you to make a degree, you will need to add those characters to make them appear on the drawing in a degree format. So let's add it like that. Capacity, like that. Meter cube. So to make a cube, or you can use this those characters to make to the power 3. So from here, let's make those characters like that. So let's save this and read it directly from here. So let's import an Excel sheet. So we will read that one. So from import, when you click on import, SEG will ask you if you would like to empty the current design data or not. So we will use the new design data. So we have those values, and let's save them. So let's save that. So we have the design data here. The equipment setting, if you would like to modify the equipment setting, we can define the equipment data like storage vessel. And here the serial number of the equipment. This serial number will appear on the drawing, and here that's the tag number of the equipment, and this tag number will reflect here on the equipment, which is the equipment name. Here the delivered plate dimensions, which is the length and width. Those values will used inside SEG to calculate the circumference of the required number of plates to make the circumference of the shell. And here you can control the units of the equipment, if it's in millimeter or inches. Now let's save that. And here from the equipment you can make a rename like that, or by using defined it from here. So that's you can do that before proceeding with creating inventor elements. When you make a rename for the equipment after creating elements on Autodesk Inventor, that will cause a problem. So you will need to define the equipment name before proceeding in creating elements over Autodesk Inventor. So let's rename this vessel like EA and click on save. When you click save like that, you will find the equipment name will be changed here, and you can make a rename from here directly. When we open the equipment setting, you will find that on the position tab you can define the position of the equipment. You can make it horizontal, tilted, or vertical visit. You can control the direction of the assembly from here. So here in this equipment we will make a horizontal equipment, and the first element we will add it, which is a blind flange. So from here let's add a cover, and here for covers you will find different type of covers or blind flanges, like flange with two raised faces, and you can add a pass partition. So this type of blind you can use it on heat exchangers, or blind with raised face. As a user defined, you can define the dimensions of the blind, and that type you can use it on non-standard blind flange. The same for ring joint flanges. As a user defined blind flange with a ring joint, so you can define it in detail. And on the other elements on the list, you will find some standard blind flanges, like RTJ blind flange according to ASME B16.5, a standard flange according to ASME B16.5 but with a raised face, not a ring joint. Large size diameters according to B16.47 Series A or Series B, from 26 inches up to 60 inch. Blind flanges according to ASME to European code. ABI flanges, user-defined ABI, RTJ blind flange, and many other types of flanges. In this case, we will use raised face blind flange according to ASME B16.5, and from here let's select the rating to be 300 and select the size to be 24 inches, and from here you can define the material of this element by different ways. You can write it directly from here, or if you would like to get it from the ASME database, you will make a search by selecting the table from here according to ASME, and make a search for the material here like SA-1500 like that. So you will get the material from here, and if you would like to add remarks regarding this material, like supplying remarks or something like that, you can make it normalized or impact tested by select one of those options and click on done to reflect the material directly here. So let's click on save. and let's add another element like a gasket. So from here we will select a gasket from this button, and after selecting this one, you will find some different types of gaskets, like user-defined gasket or user-defined gasket with a bolts. So some types of gaskets including a hole for a bolt. In our case, we will select a gasket according to SMEP 16.5 flange and select the same rating of the flange, the same size of the flange, and define the material of the gasket and click on save. Now let's add a body flange. So from flanges, and here we have two different type of flanges. This type, which is the standard flanges, and that type is the designed flange. And let's take a look on the designed flange, by the way. That we will delete it. Here you will find a different type of designed flange, like integral weld neck flange or integral weld neck grooved face. Like if you take a look to the image on the right hand side, you will find the groove of a groove inside the flange. So the raised face will be with a negative value, so it's a grooved, not a positive raised face. This type usually used in heat exchangers, or integral weld neck flat face without any raised face, or ring joint face, like that. So you have a groove for a ring joint, and many different types of standard flanges. Okay, in that case we will use a designed flange. So let's add this one and make it body flange. And when you select the node, you will be able to select from a list of standard flanges. So you can make a slip-on flange or threaded flange, lap joint flange, or RTJ flange. In that case, we will use a raised face according to SMEP 16.5 flange. Let's select the same rating, same size, and from here you will select the schedule of the flange. In that case, we will select 40 schedule, and here you will check the end thickness of this flange. And if you would like to define the end thickness manually, you can do that by check on the user defined thickness, and you can define the end thickness of the flange. Sometimes in the design you may need to define the end thickness of a standard flange as a user defined end thickness, not a standard schedule. So here this option will give you the ability to define the end thickness of the flange by hand. So let's remove it and keep the standard schedule, and here the material of the flange, and let's click save. Here let's make a run for the assembly and check the configuration of the elements, because I would like to show you an important thing regarding to the body flange, because it will not be located on the right way. Here we have the blind flange. As you can see, the elements created on behind, after that it will be assembled to the final assembly. Here, that's it. Here the flange direction not correct. You can figure that the end of the flange on the direction of the gasket. We need to flip the direction of the flange, make this facing to the direction of the gasket. So here, if you come back to the SEG, here you will find an option for this option will be available for some elements like head, like flanges, which is maybe flipped. Like when you would like to flip the direction of this element, you will select the checkbox. This checkbox will flip the element to the other direction. So when you select it and click on save and click run, so the direction of the element will be flipped to be on the right direction, like that. So when we make a cut from view, let's take a half section. like that, you will get the direction of the element on a right way. Now let's complete the main elements of the equipment, like creating a shell and a cone. So from here, let's add a CAN one. And from CAN one, as you can figure, we get a mistake, an important mistake here from the common mistakes, which is selecting another node without checking the appearing form here. This mistake, you can figure that we get a form of the flange during the selecting of the cone. So you will need to select the icon from the tree, not the name. Sometimes when you selecting the name, the form will not appear. So you will modify another node, and that may cause a problem on the file. So you will need to be sure that you're selecting the correct element. So we will need to come back to the tree here and click on the node, which is the cone. So when we click on that one, you can figure that the form will appear in a right way. So you will need to click on the icon itself to be sure that you select the correct element. Okay, here we have the correct element, which is the shell, and you will find many different types of shell, like shell as a pipe or shell as a welded pipe. So here you have a standard size of the pipe, but including a weld line, or a shell without any welding lines. You may use this type in case of making or preparing an offer, and you will not need a detail on the shell. Just make a long shell without any welding lines to get a weight. For example, if you have a long LPG and you would like to calculate the weight without defining everything in detail, just a long shell with a thickness without needing to define the welding line orientation. So you can use this type of shell, or the common type, which is shell type. In this shell type, it's common used on pressure vessels. So you can use it if you have a shell from one segment, and if you have some equal segments, like a shell from 2 or 3 segments or up that, you can select this option, which is enable segments, and define the number of segments of plates inside this shell, and this option will make the shell from equal segments. Okay, if you have a large diameter vessel, like 7 meters shell diameter, so SEG will use the delivered plate length. For example, if you that's the available plate length here, and we have 7 meters of vessel. So from here, if we scientific, so we have a by here. Okay, so if we have 7 meters, so that's the circumference of the shell, if which is 21.88 meters. So it's greater than the available plate dimensions. And to get that value, we will need at least 2 plates to get this circumference of the shell. So SEG automatically will calculate the required number of plates in this shell based on the available plate dimensions. There are different types of shell, like a shell from different pieces, like that. It's usually used in case if you have a cone, large diameter cone, and you would like to define each plate length separately, like that. Or if you have a storage tank and you would like to define each plate separately, and if you have a different thicknesses, you can use shell from different pieces and the thicknesses, so you can define each thickness of plate inside this shell separately. Okay, let's come back and select a pipe, and from here let's select the required size and the end thickness of the pipe, define the length of this pipe and define the material and click on save. Now let's create a standard cap. So from here let's add cap. And here we have this in the cap, and from here you will find a list of different types, like an ellipsoidal head as a head from an ellipse. So it's not including knuckle or crown radius, it's a half of ellipse. Another type which is ellipsoidal head with crown on the knuckle radius. So you can figure that if you take a look to the red font here on the form, which is crown radius and the knuckle radius, you will find the values according to the Hegazy code. The values of the crown and the knuckle radius for this element, and if you have a flat dashed head, here the equation of that one, standard type flange or semi-elliptical head, the values of crown and the knuckle radius. In our there are different types like diffuser head, and you can check the shape from the image on the right hand side. Convex head or flat head, hemispherical head with a straight flange, or hemispherical head with negative straight flange, like that type of head usually used on division 2, or large thickness vessels, division 1 or division 2. Cone head with a knuckle at the end, or a conical head with closed end. Many different types here. In our case, we will select a standard cap, and from here select the size and the schedule of this one, define the material of this element and click on save. Now the same option for the end cap, which is the flip option, and right now let's click on assembly to create the shell and the cap. And here when we make a section on this element, you can figure that the direction of the head is not correct. So that's because we need to make a flip on this head to get the correct direction of the head, like that. So when we become familiar with the elements and the forms, automatically you will select those options without coming back to the 3D view and check if this element need to be flipped or not. Okay, now we have the main elements of the equipment. Like here we have the main types of the pressure vessel. Now let's add some of the attachments, like adding saddles, nozzles, boot nozzle. So from here let's select the can, and from the can you will find here the available attachments you can add it to the can, like supports, openings, lifting, and external attachments like nameplate, external rebad, stiffening, things, many other options, elements. And for the internal attachments, you will get those and the platforms and coils. So here let's select the can, and from here let's add a saddle. So let's add a lift saddle and click on save. Here let's click on the saddle and you will get this form. You will find a different type of saddles. In that case we will select the lift saddle, lift type, to make the whip on the left hand side, and from here let's define the height of the saddle, the contact angle, and from here the contact angle of the wear plate, the width of the base, the width of the wear plate, the thickness of the wear plate, the material of the wear plate. Let's define the length of the base plate, the width of the base plate, thickness, the hole diameter, hole offset from the short edge and the long edge. So If you, in that case, we will make the hole on the middle of the base plate. So we have 200 millimeters width. So to make the hole on the center of that, we will make the offset to be on 100. Let's have two holes on the saddle. The location we will make it on the 300, and the orientation, you can control the orientation of the saddle. At the default it will be at the bottom, so the orientation will be 180 degrees. And let's come back here to define the wear plate offset. So if you take a look to the image on the right hand side, which is the wear plate offset, here it's the offset from the web. So we need to define the width of the web from here. So let's add an outer ribs and define the rib width at the top and the bottom. Here 150. So to define this, to get the offset from here, so that value is 200 and that one 150. So that offset will be 25, and offset from bottom will be 25. And here's the chamfer of the rib. So let's click on save. Now let's create this saddle. Here you can figure that the assembly of the saddle created on behind. If you would like to make a rendering to this element during the creation, we will activate an option for that to give you the ability to check the assembly during creation. Here we have this saddle, and you can figure that the base plate length, we may need to increase it a little bit, or making the bottom width of this saddle a little bit narrow. So you can control that from here. If you would like to control the bottom width of the saddle, so you will need to remove the straight side, and here you can control the bottom width. So let's make it 450. So when you click on save and run, so the saddle bottom width will be, you can control it like that. Okay, if you would like to make a wide at the bottom, so let's make it like that and make the base plate like that. When you click on save, so the saddle at the bottom will be with a wide sides like that, like in some traps, launchers and the receivers traps. So the saddle configuration takes that shape with a wide bottom like that. But in our case, we will make it with the straight sides. So let's check this checkbox again and define the bottom width instead of 500, and click on save, and let's click run the assembly. One of the famous mistakes here, which is click on saving during running. So sorry, let's close this here, which is modifying an element and saving it during running. Like we still if we make a modification here, like modifying the location of the saddle like that, and let's click on run. Now SEG still sending information to Autodesk Inventor, and during that you will find that this button is disabled. So if you click on save for any element, if you click on save during this process, you will get an error, because in that time SEG dealing with Autodesk Inventor and sending information and come with information to saving it inside the project file. So reading and writing over this file during this process will cause a problem. So during this process, if you would like to stop it, like during that, let's come with this value like that and click on save, and let's click on start. To stop this process, if you have many different changes, you will need to click on stop button one time and wait to stop the assembly. So SEG will complete the element that modifying and stop after that. If you have many different elements and you would like to make a stop, just make any save after getting this button ready to start the assembly. Okay, that's one of the common mistakes, which is saving during the running the assembly. Okay, now let's add another saddle. So from can 1, let's add a left saddle, a right saddle. Here. And let's select another type of saddle, which is saddle with a left or a right web side. So from here, let's define that. Same options. And from here, define the location of the saddle. The offset, the top and the bottom widths of the saddle. Let's keep this value and we will modify it to show you how you can control the top and the bottom widths of the web. And come back here and click on save. And before making that, we will change a setting here, which is make a child preview and parent preview. Those options will give you the ability to make a rendering for elements during creation. So let's click on save and click on start assembly. Here you will figure that you have the ability to make a preview for the elements during creation on SEG. Here we have the first element on the saddle, which is the web. After that, the base plate, and here the outside ribs. And you can figure that the outside ribs with a top width and the bottom width. Here you have this saddle with two different values for the web width. Here you have 250 millimeters top width and 150 bottom width. So now let's correct this value and click on save. And let's run the assembly. Here you will get the update for the web. Let's make one more option for the saddle. Let's make this saddle as a sliding saddle. So you can figure that both saddles are with a straight hole. One of them, let's make it with a slot hole. So for the right saddle, we will select it, and from here we will select this checkbox, which is sliding saddle, and define the slot length with 50 millimeters and click save. Now let's click start assembly. Here we have this slot hole on the saddle. Okay, here we have this support saddles, those support saddles here on this vessel. Now let's add some other attachments to this vessel, like let's adding a boot. Okay, one more point before going with boots, which is the reference point or the datum. Here we define the location of this element to be 250 millimeters. So where is the reference? Okay, if we make a quick drawing here, and let's add this view for the equipment here. If we make a center line for this saddle and that saddle, if we measure the distance from this center line to the seam line of the shell, that's the location that you defined here. So the location of the element, as we discussed, on our presentation here, the location of the element related to the start point of the main element. The main element, which is this child located on it. So the same for the second saddle. Here we have this one. So the location will be related to the start seam line of this equipment. Let's close this drawing, and now let's add another element like a boot, and from here let's add a boot nozzle. And when you select this nozzle, you will find a different type of nozzles available in SEG, like nozzle from pipe, nozzle from blades, a tangent nozzle from pipe, tangent nozzle from plate, a long weld neck nozzle, a long weld neck nozzle according to European codes, self-reinforcement long weld neck nozzle, and many other types like self-reinforcement hub, nozzle with integral hub with lips, many different types, more than 25 types. And by the way, on the next release, which will be available by the end of this week, which is v4.04, in this release we will submit new types for the long weld neck nozzles, but with a ring joint facing. This type was not available, but on the next release, the long weld neck nozzle with RTJ facing will be available on the next release by the the end of this week, inshallah. Okay, now let's add a boot as a nozzle from blade, and that's the outside diameter of the pipe. So let's make it, let's say 350 millimeters, or make it 70 millimeters. So that's the outside diameter of the pipe. That's the thickness of the pipe, the longitudinal welding line orientation, and the location of this one. So let's keep this value, and the orientation, let's make it 180 degrees, so it will be at the bottom. And let's add the reinforced pad, define the rebad width and the reinforced pad thickness, and okay. Very good. That's, and here to define the projection of this one. After saving, let's open the calculator and define the projection of this pipe. So from here, let's select, let's define this 800 millimeters from the vessel center line to the seam line of the shell. Here, that's the projection of this nozzle outside the shell. So if you would like to increase it a little bit, so let's make it like this, and let's click on save. So that's the projection of this nozzle. And to add another element to the end of this nozzle, so the nozzles, you can connect elements to the end of this type of element, which is nozzle or coupling or something like that. You can add an attachment to the end of this element. Here on the tree, if you take a look, you will find an external connection. If you select it, you will be able to add another element to the end of this nozzle. Like in that case, we need to make a boot head. So when you select the external connection of the nozzle and select the boot cap, let's add a boot cap. Here you can add another element to the end of this nozzle. Here let's add an ellipsoidal head with crown and knuckle radius, and let's define the inside diameter of this one. Define the thickness, the straight flange of this element, the minimum thickness after forming, and from here let's select the flip option to flip the direction of the head. And now let's run the assembly. As we discussed during the running of this option, if you would like to stop it, just click on stop. Okay, after that, SEG will complete running the current element. After that, will stop directly. So that means SEG will not proceed on creating the head. So you can make a saving or editing after that. Here you can figure that we stop here, and the bottom cap still under modifying, and SEG waiting for our command to proceed with assembly. Here you can figure that we have this nozzle and we stop the assembly. After modifying, if you would like to modify something, you can complete by clicking on the start button to start creating the other elements. Here we have this boot head, and you can add attachments to this head because it's a main element here. So when you select this boot head, you can figure that you can add elements here. By the way, we didn't talk about the toolbox. Here inside the toolbox, you will find the same elements here, which is they are appear on the elements. By the way, we're talking about moving this element and by moving and drag and move to the place that you would like to make it appear. You can close it and make it appear again by making the show tool bar appear like that. You can make it at the top or you can close it. Okay, so when you select a main element, you will be able to add attachments to this element. But if you would like to add a nozzle to another nozzle, if you selected this nozzle, for example, you will not be able to add elements. You will find this tab is empty. No elements you can add it to this nozzle. So in that case, we will use unreal elements. So it's a trick on SEG. So you can use this type of elements to create attachments to another attachments. So here you can use that to create an attachment to another attachment, like nozzle, attach it to nozzle. So what is the unreal elements here and how we can use it? Okay, here if you selected the external elements and selecting a shell, let's add a connection. If you select this connection point and go down here on this list, you will find a connection point for a nozzle. And if you check the image on the right hand side, you will find that this element is not a real element, but you can use it to create a coupling or a nozzle to another attachment. So let's check that. In our case, the boot created from plate with outside diameter 370 with a thickness 10 millimeters. So let's come back to the connection point, and from here let's select this connection point as a plate, shell from plate. So we will need to define the inside diameter, not the outside diameter. So the inside diameter will be 350 and the thickness will be 10 millimeters. So here we have unreal element to cover the shell element, okay, to be able to add attachments to this element, which is a boot. So when you select this element, you will be able to add different attachments like nozzles, lifting lugs, saddles, external attachments, many different things. So here, let's select this one and let's add a nozzle. So let's add a nozzle in 3A. Click on save, and here for N3A, let's add a long weld neck nozzle and select 300. Select the size to be 2 inches, and for the location, if we take a look here, we add this element here on the seam line, which is the unreal element, which is the shell. So if you add the location with a positive value, and we will check that, it will go outside the boot. So we need to make the location of this nozzle with a negative value. But let's keep it with a positive value right now. Change the orientation and click on save. And after clicking on save, you will be able to define the projection of this one. So let's make it 450. So that's the projection of the nozzle. And now let's click on Assembly. Here the long welded neck nozzle will be created. And the location of this nozzle will be 250 with a positive value. So you will figure that it will go outside the boat. As you can see, the location with the positive value. If we measure that value, so let's create a drawing and show you that. Here we have, let's increase this value. And if you measure, let's add a center line here for this nozzle. Okay, and let's measure from the seam line to here. You will find that the positive value of the nozzle make the nozzle outside the boat. So to make it located on the shell, we need to make this value with a negative value. So let's make it 150 with a negative value and click on Save. Let's add another nozzle. So let's select the connection point here, and from here let's add N3 and click on Save. Click on Add. Another common mistake, if you make this nozzle looks like in 3A like that and select same part as and click on Add, you will get this nozzle looks like in 3A but without an external connection. You can figure that in 3A has an external connection, but in 3B not getting an external connection. So to solve this, you can make N3B by that way, creating it in 3B and click on Add. After that, here from this form, you can make it looks like N3 by making it from here and click on Save. Okay, now if you select another point and make a refresh for the view and select N3 again, you will find the same information of N3, the same location, and from here we will need to modify the location. So let's make it 400 millimeters from the seam line. So let's click on Save and recreate the nozzle. So that's N3A. Okay, so we have those nozzles on the boat by using the technique of unreal elements. Okay, and on the without this option, you will not be able to add a nozzle to a nozzle or another attachment to that nozzle. So by that way, if you would like to add another external connection, like adding a stiffening ring or add a nameplate on the boot or something like that, you will be able to add any other attachment to this connection point. Okay, one more option here for the adding an attachment, like adding a nameplate. Let's add a nameplate to this shell. So here let's add nameplate. Here on the nameplate you will find many different types for the nameplate bracket or the nameplate bracket support. So in that case, let's select that option, and from here let's find the input and the thickness, the location, orientation, and the support. Let's add a ASME nameplate and find nameplate, and let's click on Save, and let's run the assembly. Here we have the nameplate bracket and nameplate bracket support, the ASME nameplate and the client nameplate. Here we have that here. Now let's add a forged hub nozzle to the shell, and let's deal with the option of this forged hub. So from here, let's select the shell, and from elements, let's add N1. And from here, let's select a standard Hegazy forged hub. As you can see, the end of this forged hub is a standard end, like the pipe. So you can select the size and the rating of a pipe, or if you would like to define the end thickness of the forged hub. But here you will connect a standard flange or a standard element, like a standard elbow or something like that. There is another type which is user-defined forged hub. In that case, the forged hub completely user-defined. The inside diameter, the outside diameter, the hub thickness, everything you can define it from scratch. So in that case, we will use a standard Hegazy forged hub. Select the size to be, let's say, 10 inches with a scalable 60. Select the forged hub height, the forged hub thickness, and the bevel height. So the bevel height here, if you would like to calculate it with 45 degrees slope, so the bevel height will be the hub thickness minus the thickness of the end, so will be 40.7. So that's the hub height, which will give you 45 degrees. So let's copy this value and paste it here. Okay, and name this nozzle as and click on save. Here, before calculating the projection of this nozzle, because if you calculate the projection right now, you will get the projection from the facing of this pipe. But we need, in that case, we need to calculate it from the facing of the flange. So after adding a flange, so from here, let's select the external connection of this point, and let's add a standard flange. So N1 flange here. So let's select as flange, select the rating, the size 10 inches, like the forged hub, the same scalable of the hub, and let's click save. Now when you come back to the nozzle and open the calculator fork, you will be able to define the projection to the facing of the nozzle. So from here, let's define the projection to be 100, and here that's the projection of the hub. So let's minimize this value a little bit. Here that's the projection, and let's click save. Okay, so the projection reflected here. And now let's click on assembly to start the assembly of this nozzle. So I think the hub height, it's not defined in a correct way. So here I think that one, and we need, that's the hub height, and here we need to add a dot. Okay, it's 27.3. So let's click on save, and let's click run again. So that's the correct hub dimensions. Like that. We need to minimize the projection a little bit and change the location of this nozzle. So let's come back to the nozzle and define the location to make it like that, and save. And from calculation, let's minimize the projection a little bit like that, or let's make it 600. Click on save and start the assembly. Here we have this nozzle. We change the location and the projection. Some other options related to the nozzle we need to discuss. When you open the nozzle table from tables, when you open the nozzle table here, you will find the nozzles that we defined, like boot, N3A, N3B, nozzle N1. Here you will find the welding options appears as a default with a 0 value, and the welding style stayed at 0. Here the projection of nozzles appear on the external projection. So we need to modify the welding style from here. So when you select a nozzle, for example, you will be able to define the surface of this nozzle, and you will be able to define the weld detail of this nozzle. SEG include a standard welding detail, so automatically the welding detail number will appear here for this nozzle, and you can select between single V welding or double V from here. So in case of using single V, the welding style number will change, or double V, the welding style number will change. The same here for the cladding option. If you would like to make this nozzle without clad, or a clad on the parent element like that with weld overlay here, or a clad inside the parent element and the child element like that, so the welding style will change. In our case, it's no weld, and here let's define the weld, the fillet weld, which is dimension A. Let's make it with 8 millimeters, and let's click on save. Now when you check the nozzle table, you will find that the weld style changed and the weld option. Let's select the boot, and from the boot let's select the weld options. Automatically here you have a single V and no clad, so you will need to define this 8 and 8. When you click save and come back to the flange table, when you select the boot, you will figure that the weld style changed automatically and the fillet welds here. All of those information will be reflected to the nozzle table on your drawing if you select it. So let's define that for nozzle N3A and nozzle N3B. Here you will find that changed on the welding welding information of this nozzle. Okay, let's add another a lifting lug to this shell. So from here let's add a tailing lug, for example. I know it's a horizontal vessel, but let's check that option for tailing lugs. Add a tailing lug. Here let's select the tailing lug, and let's define those dimensions. We have let's define the bottom width here, the dimension D, the offset E of, let's keep those dimensions as they are, and same here. If you would like to add a cooler, and click save. Now let's add the lifting lug, and in that case we make it as a lifting trunnion. And let's make it as a trunnion from pipe. Let's make it with 4 inches pipe. Schedule 160. Define the width and thickness. The projection. Large diameter. Small diameter. And here some other options, and we have one trunnion on the left side, so that's the tailing lug. And here that's the trunnion. Okay, we need to change the location of this trunnion a little bit. And we need to add another one on the other side. Here here we have an option to make them with a pattern. Let's check this option and show you why we will not use it on the horizontal vessels. Because the pattern option here on the you can use it on vertical visit because it will give you a symmetric configuration for the trunnion, but on the horizontal vessel you will get the lifting lug not on the right side. So let's check this and I will show you how we can make that. Here we have this lifting lug. You can figure that one on the correct side, but the other one is not on the correct side. So how we can do that? So we will need to remove that, make it one again and click on save. And let's add another trunnion here, let's add another trunnion, which is trunnion 2. And in that case, we will make it looks like trunnion 1 here. So the same information, but the orientation of the lug here, we will change it to be, we will increase it with 180 degrees. So when you click on that, that's the second trunnion. Okay, so we need to change the orientation of this trunnion. So from here, the orientation, we keep it on 90 degrees, but it should be that. And click on Assembly. So we need it on the other side, So now we have those lifting trunnions on those sides. Okay. Here, by that way, we can hit a simple vessel. You can add a nozzle to the bottom here or the cap. So from here, we need to add a nozzle on the bottom cap here. So we will select the bottom cap of the boot, and from here, let's add N4. So N4 will be a nozzle with a nozzle from pipe. Let's make it 2 inches nozzle with a scalable 160. Make the offset from the vessel center line to be 0. Like that. That's the same as a nozzle. And let's add an elbow to this nozzle. So from here, let's add N4 elbow. So we selected the external connection node and add another element, which is an elbow. Let's select the elbow type. Here you will find the list of elbows. Let's select an elbow with a 90 degree as a long radius. And from here, let's make it 2 inches. Select the same rating of the pipe and select save. Now let's add a pipe here in 4. So let's select 2 inches, the same schedule, and projection. And from here, after that, you can add other elements. Here, let's add a T. Okay, and let's check the options of the connected T. Here, let's add N4 T. If you select this T, you can figure that you can create an equal T or reduced T. You can make a threaded T or a socket weld T. Here, let's select an equal T with 2 inches with the scalable 160. And here an option like for connecting connect this T from branch. If you select this option, the T will be connected from the branch to the previous element, which is the pipe. If you deselect it like that, the T will be connected to the pipe from the end here. So let's assemble that and check the options. So let's click save and click on start assembly. We have this pipe. We didn't define the projection of this pipe, so it's kept on the default value, which is 300. So when we come back to the nozzle here, you can figure that the projection is 300. If you would like to modify it right now and make it like that, don't save. As we mentioned, during saving, during running, you will get an error on the file. So you should stop the assembly first before making saving on the file. Here, here after modifying this, you can from the calculator you can modify that by calculating the projection of model like that, and automatically SEG will draw and calculate the projection of this one, and you will get the value here. So we can increase it a little bit and you can figure that SEG will start creating a sketch and calculate the correct projection, and when you click save you will get that. If we come back to the nozzle, here we have this elbow. Let's click on start simply. As you can see, the T here connected to the pipe from the end. But if you would like to connect this T from the branch, here you have an option for that. So if you select the T, you have an option here which is connected from branch. And before selecting it, you can check the ends of this T. You have a branch here. If you would like to connect something to this branch, like another pipe or something like that, and you have the second end, you can connect. So they are appear here, so you can make elements on those connections. Here let's select this T and select branch connection and click on save here, and you can figure that you have two inlets now, not a branches. So when you click start, you will find that this T will be connected to the pipe from the branch like that, and you can control the orientation of the T from here. So when you, for example, make it on 90 degree and click on simply, you will be able to rotate this T like that, so you can control the orientation of the T. Now let's add some connections to the ends of this T, like adding another two elbows. So from here, let's add N4 elbow 2. Okay. And on the other connection, let's add elbow N4 elbow 3. When you adding one of the famous mistakes, when you adding an element to a child, like this T in that case, and when you select same as, let's say N4 or N elbow 4, like that, when you click add, it will not be located on the inlet 2. Let's check that. If you click add, so the element will be added to the external connection here. So we need to delete this here. So to make something like that, you will need to add the element first, which is N4 elbow 3. And after adding it like that, you can change the type and make it looks like elbow N4, and the same for that one. Let's make it looks like elbow N4. So when you check it, you will find it 2 degrees, long radius with 160. So let's run the assembly. After running that, you can rotate the elbow direction if you find it. If you find that you will need to change the orientation of this one, so you can do that after the assembly. Here you will get the orientation on that direction. So if you would like to rotate it, you can do that by changing the orientation of this one, like make that one 90 degrees, for example, and save. So the orientation of the elbow will be changed like that. Here you change the orientation of this elbow to come on that direction. Here from the tree you can add elements after that element for the inlet one, for example, which is the bottom inlet. Here let's add another pipe or a flange, for example. Let's add N4 flange. Here let's add sorry, I add a design flange, so let's delete it, and from here let's add a standard flange. Here, select this one, select the rating, size and schedule, click on save. If you click assembly, now you will add an element after that element, like that. Okay, now you have this flange connected directly to that elbow. Let's say on the next revision, the client asked to add a pipe here between this elbow and the flange. So that means you will need to add a pipe here between those elements. How we can do that on the SEG tree? So here we need to add a pipe between this elbow and that flange. To do that, let's select this inlet, and from elements let's select a shell type, and let's add N4 pipe. Okay. And here we have this pipe. Let's define it as 2 inches pipe with a schedule 160. Define the length to be 200 millimeters. And when you click on assembly, if we click on assembly, you will figure that the pipe will come after the flange, not previous the flange. So how we can modify that? How we can arrange that in a correct way? Here you will find an option make you able to move elements. So let's click right click on the pipe, and from this shortcut menu you will find a move option. So from move you can move it, move after or move before. In that case you can make it move after elbow 2. So when you click on move, you will find that the elbow, pipe and flange, that's the correct arrangement. And you will figure that the color of the element changes to the blue color. Here we have 3 different colors on the tree: the black color, red color and the blue color. Black color means like that. The black color means this element is created on Autodesk Inventor and assembled in a correct way. Okay. The blue color means that this element is created on Autodesk Inventor but not assembled yet. That means here SEG will rearrange those elements. As you can figure, the arrangement is still the same: elbow, flange, pipe. But here on the tree it's elbow, pipe, flange. That means SEG will need to make a rearrange for those elements. So when you click on start and come back to Autodesk Inventor, you will find that the arrangement of elements will be rearranged. Here, still updating. Here, you will find that the arrangement of elements become in a correct way. If you come back to the tree, the element color will come black again. So let's add an element here directly to the end of this element, like a flange, standard flange, N4 flange 2, and let's make it slip-on flange, 2 inches, and let's make the overlap to be 5 meters and click on save. Now when you click run the assembly, sorry, here you can figure that the red font color, that's for elements don't created yet. Now after creating this element on Autodesk Inventor, you will find this color will be moved to black, and here still updating. Now after creating it, the color of this element changed to black. Here you can figure that we have this slip-on flange here on that elbow like that. Okay, so here we will proceed. If you would like to make the same steps by adding another pipe or something like that, we will make the same steps. Here, let's add 4, 5, 2. And you should make all names as a unique names. Don't repeat the names on the tree. Here, let's make 2 inches, 160. Save. And now we will use move after, not move before. We will select the flange, not the pipe. Let's select the flange, and on the flange, let's make it move after, okay, the pipe too. Okay, so here you can figure that we have 3 different colors. The black color for this element, which is already created and assembled in a correct way. Here we have this element, which is a pipe with the red color. That means it's not created yet and not assembled yet. And the last one, which is the blue color, that means this element is already created on Autodesk Inventor but not assembled in a correct way. So when you click on assembly, we will get a pipe after the elbow. After that, the flange will be reassembled to this pipe like that. Okay. Here we make this simple vessel to discuss some points regarding how to create attachments, how to make a nozzle over a nozzle. And here we have this sample received from your site before, and let's create the same configuration, which is we have this inside vessel, which is we have a flange here. After that we have a shell, have a cone, reduced cone. After that we have another shell. Okay, but at the end of the shell we have nothing connected. We have another shell here with a cap. So how we can do that? Okay, we by using the techniques available in SEG. How we can do that? Because as we discussed here on that option, the element will be connected to another element by using the UCS. But here, how to make another element from different point, not connected to the end of the last element, and how we can make the outside configuration by using a cone here with another cone with another flange. Okay, on the same vessel, let's create another vessel here from this one. Let's create another vessel, which is BB. And let's so now you can figure that we have 2 vessels, the first vessel and that's the second vessel. So on the second vessel, let's define it as a vertical vessel. So from the setting, we will open the equipment setting and we defined it as a vertical vessel, and let's start it from bottom to top. So the arrangement of the vessel will be started from bottom to top, and let's click on save. So from here, let's add a body flange, F1 for example, and let's make it as an ASME flange according to with a large diameter. So let's make it 32 inches with X strong in the thickness. Okay, so it's according to ASME 16.47 for sizes more than 24, and according to series A. So let's click on save, and let's add pipe 1. Okay, and from here let's select a pipe with a 32 inches with a scalable X strong with 50 millimeters the length, like that. So we add this flange, we add this pipe. Okay, so we have this pipe here. We define the dimensions of this pipe, and let's create this simply. Here we have this flange. After that, we will create the shell. Now let's add a cone. So let's check the inside diameter of this one. So from inspect, let's check the inside diameter. So that's the inside diameter of this pipe. So let's add a standard a cone from a plate. So let's add cone. Okay. So from here, let's make it as a centric cone. That's the inside diameter. That's the thickness, the longitudinal building line orientation, the length, and the end thickness. So let's make the end thickness as a 1 meter. 1 meter, and height, let's make it 300 millimeters. Okay, and here you can figure that when we create that, if you take a look to the image on the right hand side, that's in case of horizontal vessels. In case of vertical vessels and flipping the direction, we will need to flip the diameters. But right now, so we will need to get this value here and that value there. But let's create it like that to show you why we need to flip those values. After creating it, you can figure that we will need to flip the values in casing of flip the direction. So here, let's flip those directions like that, and let's add another shell to this vessel. As you can figure, after that cone we have a long shell here. So from here, let's come back on this shell and create a shell, which is shell 1, and let's make it as a shell without building lines. Let's make it with 100 millimeters and make this length as 4 meters length, for example, and click on save. Now when you click on start assembly, the cone diameters will be changed. After that, we will get the pipe connected to this one. Okay. Now we need to make this configuration, which is we have a shell here start from another point here. After that, we will need to make end cap to this one. So how we can do that? By using the overlap option. So here from elements, you will find, if you select the vessel, you will find an element here called gap and overlap. We talked about it on the presentation. Here, if you would like to make a gap, you can make a gap between elements, and if you would like to make an overlap, like this cone with this shell, you can use the overlap option. So from here, we will come back to this vessel and add that element, which is overlap. And from here, let's select the overlap, and we'll find this overlap to be 2 meters 0.5. K2 start from this point, for example. So from here to there, let's define it as half meter. So we defined it as 2 meters 0.5, and let's click on assembly. And before that, let's add another shell, which is CAN2 shell 2. And from here, let's define the inside diameter of this shell. Let's make it shell without welding lines. So let's make the length of this one as 3 meters. Sorry, the inside diameter 1 meter 5, and the length of this one as 3 meters. And click on save. And let's add an end cap. So from here, top head. And from this top head, let's define it as a user-defined crown and the knuckle radius. As you can see, we have crown and the knuckle radius as a user-defined. So we can, by using this type of head, which is with a user-defined, you can define the you can define the crown radius and the knuckle radius like that. And let's click on save. So you can figure that we make an overlap, and that will give you the ability to start from another point with not the end point of this shell. Here, like that. So if we take a section here, so let's click on a view button. Tab and make a half section here like that. So you can figure that we moved from this end to here by using the overlap to start from a different point. Okay, come back, not go forward like that. By using a gap option, you can move forward to make a gap, and by using the overlap, you can come back to making an overlap like that case. Okay, now let's come back to this one again, and here you have a cone, after that a shell, and another cone and body flange. Yeah, so to come back, we come here to this point, and we need to come back here. So from this point, if we let's say let's make a quick drawing here. Let's add this view. Here we have this point now, and we need to come down here to a point here to make a cone. Okay, so we need to move back again by using the overlap option to start from a certain point here to make another cone. So let's come back here to make another overlap by using this one. That's overlap 2. So from here, by selecting the overlap, let's select overlap and define that like that. Okay, and let's add another cone 2. And here let's define this diameter to be the outside diameter of this cone. So the inside diameter, the start inside diameter here should be the outside diameter of this one. Okay, so we will write this value here. Okay, and the large value will be, let's say, 2 meters. And the height will be like that. And let's click on save and keep simply. So you can figure that we create another cone here, and from this cone end you can connect another elements like this can and another cone, another shell, and the body flange. So let's create that. So from here, let's come back here and let's add shell 3. So with the shell inside diameter, you can figure that here one of the most common mistakes, which is selecting node without checking the appearance form. Here you can figure that we select the shell and nothing appears, so we need to click on the icon to select the correct item here. So let's select shell without welding lines, define the side diameter, the length, 4 meters. Let's add another cone 3, and let's make it looks like cone 2. Okay, when you click add, and just we will need to flip the values. So that value will be here and that value will be there. Let's add another can, so shell here, and we could make the end diameter here looks like the standard one there. So let's measure, we measured that one and found it like that. So let's make the end diameter of this shell to be as a standard diameter, to be able to add a standard flange. Okay, sorry, you can figure that we talked about the same issue, which is selecting the shell, but we modify on the cone. You can figure that it's cone type. So here you should select the element during the selection in a correct way. So let's make it as a pipe when 32 scalable X strong, and the length let's make it 400 millimeters, and let's add F2. So from standard flanges let's add F2. Let's make it looks like F1, so to avoid reselecting again, but here sorry, so from here let's select it looks like F1. If you make a refresh for the view, you will need to move to another node and come back to this node, and here we will make it flip and click save. Now when you click on run, we have this shell and the top cone, pipe, after that the end flange. Okay, now as you can see on the real fabrication, we need to make a connection, a welded connection between this shell and that shell, like here in your drawings we have a connection here, connection there, which is make them not fall inside each other. You will need to make them fixed. So by using some options like or some attachments, we can do that. Here to make a connection between this shell and that shell, if we go to this view here and measure the distance between here and there, okay, that's the clearance between those two shells. You can select this shell, which is the inside shell, that one, and let's add an external element, so which is shell 1. From Elements tab, you can add an external stiffening rings, okay, like that. But the external stiffening rings will close the flow. So you would like to make a connection, make the flow goes from element to another. Let's check that from here. If we make a ring 1, and from this ring let's make it as a built-up section or a ring plate like that. Let's make it as a ring plate, so the height will be that height, which is 240 with a thickness millimeter, and let's define the location to be 1 meter. Assembly. So as you can see, this ring will close the flow direction. So the flow cannot go from this side to that side because this ring closing the flow direction. So if you would like, for example, to make an opening inside this ring, you can select this ring, and if you would like to make a modification on it, you can do that manually by opening this element and, let's say, creating a sketch, like making a cut like that. Let's make that as a center line. Let's make an arc by using that type. So this value is 10 degrees, and the same value 10 degrees. The clearance from here to there is 50 millimeters. Clearance from here to there is 50 millimeters. And select points here. Like that. And make a sketch for the cut. And we can make extrude for this one as a cut option. Like that. Make a fillets for this one. And make a pattern for this cut as a circular pattern like that. So by making a hand modification, you can make a modification on this rectangular ring to make to give the flow ability to go across the area here. And there are some other types of connections. If you would like to make a long blade here, like this long blade, if you select it, you can make long blade one. So here on this long blade, we can define the height of this long blade, which is for the location. Orientation, let's make it on 30 degrees, and here the width. Okay, so let's make it like that, and you can make a pattern from this one, 8 segments, and let's keep on here simply. Sorry, I will need to flip the values here. That's and here is and click on here simply. As you can see here, if we take a section but on the longitudinal direction, so if we take a half section but from here to there, like that, you can get that this longitudinal rings can be on that direction, like that. So many different ways to make those connections by using a stiffening ring and making a cut on it for flow, or making the longitudinal plates like those plates here on the shell. Okay, so here by that way or that technique, you can make configurations like that, by moving from a level to another level. So this technique will give you the ability to make a double wall vessel or a vessel like that with different levels of shells. Okay, here that's the first part of this training, which is the 3D modeling. Now we will go to the second part, which is creating the drawings, how we can prepare a drawing for the current vessel, and how we can create our default template to use it as a reference template. Here I would like to show you something we did it before, and show you how we can make a standard border. So here, for example, you can make your standard border for your equipment to use it in your drawings. Another sample. Here, for example, you can make your own border with logos inside the drawing. So how we can do that, and how we can import it as a reference drawing to our drawings. We will get a copy from the reference drawing of the SEG, and I will show you the steps to modify on this one. Here inside the project file, we will take a copy from the reference drawing, and we will open it using SEG. So from here, we will go to the our project and open this reference template. Okay, and you will find the standard border and the standard title block for SEG. Now let's delete them from here, and let's create our own border and our title block. So from here, from borders, let's select define the new border, and let's create a new one. So from here, let's make that value as 8 millimeters, and that one from here, there, 8 millimeters. Don't define the length, because in case of defining the length, you will control the size of the drawing. So it will be A1, A3, no ability to change it. You will define the corner sizes like that, and I will show you why you making that. So let's save this as a ref template, and let's include it inside the drawing. So we will insert it like that. So we have this new border. Okay, in case of changing the size from changing the edit the sheet. So let's change the size from A3 to from A4 to A3. Now the size of the drawing, if you go inside this and measure the length, so you will find the value is changing. It's 404. So let's change the size again. Let's make it A2. So when you come back to this drawing and measure that length, so you can figure that's 578. So didn't define the length of the line, just define the corner offset from the data point. Now let's define our title block. let's define a new one, and from here let's define the height, find the width, okay, and let's add another gap here and define the height of this border as a 10 millimeters, and that one as 13 millimeters. And from here let's add the revision ref. Okay. And here we will make the revision value as a related value to the revision of the drawing, so you can control it from the drawing itself. So from here let's open the drawing properties or the custom properties of the drawing. So you can select from those if you have a custom property of the drawing, or you can add it from the revision number of this drawing, like that. So from here we will insert the revision number, so you can figure that it's with a black, with a gray color at the below and with 2 brackets here. That means that this value is a related value to the revision number of this sheet. So you can figure that the value here is a parameter value. So when we click on finish, and let's make that as a ref. Okay, so let's insert it to our drawing. Here we have this one, and if you open the properties of this sheet, you can change the revision number. Let's make it as a revision 1. So when you change it, you can figure that it's reflected here. So let's make it as a revision 0. So that's the revision number of the sheet. So by that way, you can make those values as a controlled values. Let's come back to this sheet and make our modification. Here we need to make this one as a centered and change the scale of the text to make it 3. Okay, and now let's define the position of this one, this text. Let's make it on the half of the height. So let's select that one and make it on the height. And the same for from here. Let's make it on the half of this one. Okay. Let's add another parameter for the drawing number. So we could take a copy from that one and take it here and click on done. Here let's change this value as a drawing number. Okay. And let's remove this one and add a custom property for the drawing. Here on this drawing you will find some custom properties which connected to the SEG itself, here from the project information and from the equipment setting itself. Let's select the equipment and open the equipment level, like the storage number, the service of the equipment and serial number. There are some information will be reflected to the custom drawing properties. So from here you can select the drawing number as a custom property inside this drawing and make insert for it. And now let's make this text align to the left, and let's make it on the same level of this text and define the offset from here to be in 2 millimeters. Let's click on save title block and click here. You can figure that the drawing number reflected to the custom property here, and you can change the value of the drawing number from the custom properties. Here that's the drawing number. You can change the value as DWG, for example, to modify the drawing number will be changed. This value, when you used this drawing as a reference drawing, this value automatically will be changed during the modifying here for the drawing document, and I will show you how to do that. So let's it come back to be advised. Now let's complete the modification on this one. Let's add the equipment name here. So let's make this height as 20 millimeters. So here let's add a text as equipment name. So it's a property, so it's custom property, and from here let's add equipment name. After that, add equipment tag, the tag number of the equipment. Let's select both and make on the middle. Change the size to be on 4. Now we have this text here, so let's make it aligned on vertical on the middle here, and on that one it will be on the half of the height. Now let's add some other options like the revisions or something like that. You can do anything you would like to add here. Let's add an image on this border, like so let's select the logo of SEG. So let's select that one and add it to the project. So let's come back to the project here. We have the demo of today. That's it. That's the image. So let's make an edit on it. So that's the images that we will use. You can add your image here. So let's make an edit and save it. So from here you can import this image here. So from images, we will select this image to import it in our drawing. You can scale it. So let's scale this image like that. And let's click on save. Now after modifying this title, and let's by the way let's make the name and the tag number, all of them as a TBA, sorry. So from here, from the custom properties, here we have the tag number. So let's modify it like that. And the drawing name, let's make it TBA. The same for the tag number and the name. Okay, so let's add some other parameters like location and the project name. So from here, and link them. So from here, let's add a text for location. And from the custom properties, so let's select drawing custom properties and select the location, select import. Now let's make this left align to left, and here change the scale to be size to be 3, and here let's find that to be in 2. Let's add which is the project name. From the custom properties, which is custom drawing properties, and select project name like that, same option. So we have that one. Let's make it aligned to the vertical. Another field like manufacturer. Let's select manufacturer, import this field, for that select size, make align like that, same option here, and move it a little bit here and click on save. So the values will be like that. So let's make all of them as a TBA. So for the manufacturer, for the project name, and for the location, as you can figure, the location, project name, and the manufacturer, all of those are default values. So we will close this drawing and save it. So after saving, let's close those things here. Those are the open documents. And here we have this another drawing. Now let's create a drawing for this equipment, and we have one more option we would like to discuss before proceeding on the drawing, which is the on the app setting. We have two visuals. Uh, Here for this option, which is group by overall project, this option gives you the ability, if you have two identical items in two separate visuals, like you have a flange with 4 inches with the same schedule and the same rating on two different visuals. This option will give you the ability to accumulate the identical items from separate visuals. But if you deselect it, each visual bill of material will be a separate. Okay, you get my this point? Hello? Okay, can you hear me?
Yes, sir.
Okay, so this option will give you the ability.
Sir, can you explain the two different types of project?
No, two different visuals on the same project. It's the same project. Here
okay,
we have two visuals.
Divisions.
Yes, we have two visuals here on the same project. We have this project, but we have two visuals. Okay?
Correct.
Okay, so if you would like to make submission for identical elements on the two visuals, you will select this option, which is group by overall project. So the identical items will be submitted. Okay, if you deselect it, each visual will be with a separate bill of material. Here another option for
Okay.
size. So if you can mute the voice from your side. Okay, here for the nozzle size, you can make it in DIN format if you would like to make it in DIN format. The default is NBS. So if you let's deselect this option, and from here, if you open the nozzle table, for example, you will find the sizes in NBS. So 2 inches, 2 inches, 10 inches, and if you make it on DIN format like that and click on save, when you open the nozzle table, for example, you will find the size in DIN. So in 50 millimeters, 50 millimeters, 250. Okay, and that will reflect on the bill of material, by the way. Okay, so let's come back to the setting and remove this checkbox. Another option here for sorting. If you select SEG sorting number and click on save, when you open the table, you will find the sorting come in that way, which is 1.1, 1.2. Here for the formed heads, it takes the group number 1. So those two heads will be 1.2 and 1.1, like that. And for the formed for the pipes, for example, it will take a group number 4. So for each pipe, for different pipe, 4.1, 4.2, 4.3, 4.5, 4, like that. Okay, the same for shell. But if you select the option of sort numbering, which is a default option, you will get the bill of material in that format: 1, 2, 3, 4, 5, 6. So the number will be in that format. One more option for the decimal option. You can use this fraction on the bill of material. That will be reflected on the bill of material. If you have an element defined in inches, and you can control the fraction value. That's in case of using inches dimension, not in millimeter. So you can control the fraction value from here. You can control the zooming in, or make it normal, or make zoom extend as a default. You can control the icon size from here. Okay, now let's start creating our drawing. Before this step, we need to define the custom drawing that we will use. So from here, we will import the drawing that we modify, which is that reference template inside that form. So from here, let's go inside that one and select the reference template and define the name of this one. So we will make it as a ref. Okay. And from here, let's define those values. Let's open the drawing again and show you which are those values. So from here, let's open the border and open the drawing. So from edit, we define this value as 8 millimeters and that value from top as 8 millimeters. So we need to define those values here because during importing tables, we need to know those values to add the tables on the correct places. So let's define it in centimeters. So you have here a note tell you that the border vertical gap in the centimeters. So it's 0.8 and 0.8. Okay, let's come back to the drawing and let's check the border. Here, let's edit the border. Here, the height of the border is 80 millimeters and the width is 170. So from here, the height of the border, let's define it in centimeters. So it's 80 millimeters. So here it will be 8 centimeters and the width will be 17 centimeters, which is 170 millimeters. So the values will be defined here in millimeter. And now we will append this drawing. So now this drawing become a reference drawing, but will not be used as a reference drawing in this project. To make it used in this project, you will need to set as default. Click on this button and you will get this checkbox here selected. That means this drawing will be used in any drawing you will create it in SEG after this process. Okay, if you would like to make a modification on this one or add another references, you can add many other references here and you will get a list here. And when you select one of those, you will select the row. You can select set as default to make this drawing as a default drawing for the current project. If you would like to make update, like modifying this width, for example, make it 20 centimeters, you can make an update to reflect it so you can figure that the value is changed. So let's make it back and click on update so it will be reflected here if you would like to make an update for the current project. Now let's create a drawing for this equipment, for the horizontal equipment. Let's create a drawing. So from here, let's right click on the vessel and click on create drawing. And from here you will get this form. This form includes the orientation of the border. If you would like to make it on the right hand side or the left hand side, make it top, make it bottom. Or you can control the orientation of the drawing. You can make it as a landscape drawing or portrait drawing. So let's make it as a landscape and make the title block on the left bottom hand side. Select the size of the drawing as A1 and you can figure that the height and the width of the drawing automatically appear here in millimeters. Okay, and if you select it in American format, which is in inches, the value will appear in inches. So if you select B, that's the height in inches and the width in inches. And you can make a custom size by defining the height and width manually. But here we will select a standard size, which is A1, and here we have the height and the width of this drawing. Now let's go to the second tab, which is the active views. We need to add some views for this equipment. We need to add 2 views let's close this. Okay, we need to add 2 views on the drawing. One of them, that view as an elevation view, and another one, which is that view as a back view. So how we can do that from this form? So from this form, we will select that view and select the back view like that. So the second view will be on the right side of the original view. That's the original view, and the second side will be on the right side of this view. And let's make the gap between them as a 4 centimeters. So you can check this note here, which is all spaces are in centimeters. So we will define the gap between views as 4 centimeters. And from the view orientation, we will select the orientation of the main view, which is that view, the original view. Okay, so from here you will select the elevation view orientation. That means if we come back to the 3D model here, if we select the left view, that will be the elevation view. Okay, and if you select the top view, which is that one, that will be the elevation view. If you select the right view, that will be the elevation view. So in our case, we need to make the left view is the elevation view. So we will select the left view from here to make it the original view. And from bottom here, you can select the style of lines. If you would like to make it visible or hidden, so that's for hidden lines, or visible lines only, no hidden lines. That's to make a shading, which is the true colors for the elements inside the drawing. In our case, we will make it with the hidden lines. Define the position. So the position of the elevation view, the center of this view will be located in 30 centimeters from bottom left side. Let's make the scale 1 to 16. And from here, let's select the tables needed on the drawing. So let's select the bill of material, the design table, the nozzle table. And for notes, you will find some notes, standard notes. You can import your notes from this form directly as an Excel sheet. You can edit or add. So if you select the row from here and click on edit, you will be able to edit the value of the row. Or if you would like to add another comment like that or another notes, you can add it by that way or by selecting it and delete the note. From the welding details, you can open the SEG welding detail library and select the required welding detail from this form like that. If you have an elbow, you can select this form. Select detail for the saddle connection and the nameplate welding option. So you can select from those values. You can add a client document list and a visual document list. Now let's define the drawing name. And the document number. And the revision table. So from the revision table, let's make editing. So it's revision 0. And click on save. Let's add some other empty rows like that. And from the design style, you can create your sheet drawing from 3 different sheets. There is an option to make the drawing from different sheets. So I will show you a sample for that. Here, for example, in the general arrangement drawing, no place to add the bill of material table here inside the drawing. The drawing is very tight. No place to add another table here to add the bill of material, because this equipment is a huge equipment, a little bit, and the bill of material of this equipment is a little bit huge. So we will make a sheet here. If you take a look here for the sheet number, this drawing is sheet 1-4. So you can separate here in this project. We separate the bill of material on a separate sheet. So that's in separate 2-4. We add the bill of material in a separate sheet because we have a huge bill of material. So we separate it on a separate sheet. So from here, you can select a number of sheets that you would like. For example, if we select 2 two sheets, you can select the size of the second sheet. And for example, if you would like to separate the bill of material, you can separate it and move it to separate to sheet number 2. But in our case, we don't need that, so we will make it as a design sheet 1. And all tables will be on the same drawing. Now let's create the drawing and click on create. Now you can figure that we used the reference template here. And you can figure that we have the revision table. The bill of material will be filled automatically and takes place automatically. The design data table, the notes table, and here the nozzle table. After that, the welding details will be created. As you can figure, the scale of the main view, we need to increase it a little bit and adjust the location of views. So after finishing adding the welding details, here's the last one. You can figure that the border content is a change. Here the drawing number is reflected, the name of the vessel and the vessel tag, the fabricator, the gas, the project name and the location. If you take a look to the project information, like the fabricator, it's TBA here. So when we change it, so let's change it to be SEG CAD Solutions and click on save. Okay, so we saved the manufacturer, and let's come back to the drawing again and click on drawing, and we will update the drawing. During the update, we will change the scale of the equipment. So from here, let's come back to the scale and change the scale of this vessel to make it 1. And the location of the view, so let's change that one a little bit and click on create drawing. Now the scale of the vessel will be modified, and the manufacturer value, here you can figure that the manufacturer value will be changed, because the custom properties of this drawing reflected to the properties here for the project or the vessel. So when you change it in SEG file, it will be reflected here, and you can make your custom properties too. So for example, if you would like to add a custom property here inside this drawing, like let's say designer, and you would like to add it here on the border. So when we come back to the border here, by the way, you will need to make that on the reference border, because you will, if you would like to use it on another project, you will need to modify it on the reference drawing. But here I will modify it on that border. So from here, let's add. And let's add the new custom property, which is the designer. Select that. So we have that value here. Let's change the scale a little bit. Let's make it 3. So we have that value here. So the value is changed here. So we can make a modification for the length of this one. Save. So you can make your custom properties in the drawing. Okay, now let's make some modifications in this drawing, like adding a tag for nozzles, add the location and the datum line, add the balance for the bill of material. By the way, I will show you something will take maybe 3 or 4 minutes, which is the balance tags. So when we from balance, when we select balance, you will find a different type of balance here. you will find it on the SEG drawing only. If you create a standard drawing from Autodesk Inventor, from the balance, you will not find those type of balance. The same for dimensions. In SEG will create a standard balance and for SEG to give you the ability to select between them. Here, from the balance, if you select the item number in the bill of material or the item tag. For example, if we select this nozzle, so let's add a center line to this nozzle, for example. If you select this nozzle from here, and during selecting nozzle tag number, and from here select parts only, you will be able to add the tag number of this nozzle, which is defined here. If you take a look to this nozzle, we add to the shell, we add N1, which is located on the shell. So the name of this nozzle is N1, so it will be reflected here to this nozzle by that way. If you select this lifting tranium, for example, it will appear as a lifting tranium. If you select this nozzle, let's add a center lines for those nozzles. So when you select a ballon, after that select nozzle tag. When you select this one, you will get the name of this nozzle, which defined it in SEG3. Here on the boot, we have N3A and N3B. So when you select it, it will appear here. Another type of balance, which is item number or part tag. Like when you select this cap, for example, you will get this tag, which is the definition of this item. It's standard cap, NBS 24 with a scalable 40 inches and height كذا. And here for the blind flange, you will get this definition for this cover, for this standard flange. That's the definition of the flange. That's in case of using a balloon and select a part type. If you select item number of the balloon, when you select those, for example, select the shell and the cap, you will get an empty balance. No value here. That's because SEG making a process which is accumulating the items. Here, if we open this bill of material, for example, you can figure that for ribs, for example, we have 4 identical items for the ribs, and for the web blade or wear blade of the saddles, we have 2 identical items for the 2 saddles. Here, for the wear plate of the saddle, it's identical from the wear plate here. So that means SEG make sorting and make a summation for elements during the bill of material calculation and accumulate the identical items and give them an item number here. So to reflect this item number, so we have this ellipsoidal head. To reflect this item number on the item, we need to make one more step, which is we open the assembly, which is the update item number. Okay, this process may take between 3 or 5 minutes. It depends on the number of elements on your project. So let's click on update item number. So this process will reflect the item number balloon in each item here. So this during this process, I will take a break to 5 minutes, okay, and will come back again to the training. I will take a break for 5 minutes during this process. Okay, thank you so much. Okay, the item number now updated. As you can figure, the color of this button become green again, and the start assembly is activated. Now if we open the drawing, automatically you will figure that the balloon values now filled with a number. That number will be related to the drawing here. So when we select item number 9, for example, and come here, item number 9, that one is a standard CAD, and that's the technical characteristics of this element. Here item number 10, if we open the bill of material, item number 10 is a seamless pipe, and that's the definition of the pipe and the length of this pipe. Item number 14, if we get item number 14, okay, it's a blind flange, and that's the definition of the flange. So by making this process, you will reflect the number of the item number to the balance. That's in case of needing it in your drawing. Okay. So let's change the scale a little bit of this drawing. So from here, let's open the drawing again. From create drawing, and from view orientation, let's change the scale a little bit. Let's make it 1:8, and let's move this view a little bit here to the left side. So let's make it 22, and let's increase the spacing between views. Here we have those two views, and the spacing between them is 4 centimeters as we defined here. The spacing between them is 4 centimeters. So from here, let's increase the spacing. Let's make it 5 centimeters and click on create the assembly. Now we make that. So we need to, after creating, increasing the scale, we need to move that view a little bit to the right side. Little bit more. By the way, you can make this modification by hand by moving this view up like that or right like that. But if you try to update this drawing again, like creating on create drawing, the default locations on the drawing will take place again. Okay, so by that way we create those views, create those tables, and you can make rearranging for those tables by hand. So for example, if you would like to move N1 at the top, you can move it like that, and move N4 after N3. The boot, you can move it at the bottom like that. So you can rearrange those values like that. You can remove some tables, like if you would like to remove the orientation table, so from here you can remove the orientation table. For example, you can remove it from the list, so it will be removed from here, or you can add it again if you would like to add it again to the drawing like that. And from SEG itself, you can control the nozzle tables from the column setting. You can select the required column that you would need to export it to your drawing. Now let's add some dimensions to this vessel. So let's add some center lines here and there. That's nameplate. Okay, now let's add dimensions, like adding the projection from the center line to the bottom of this vessel, the projection of that nozzle. Here's the projection of those nozzles from the center line, so let's add the center line here. So let's add the projection facing of the tank to the center line of the vessel, like that. The location of those nozzles from the seam line. Adding a reference point here on the elevation view, so let's add the reference point, so that's the datum line. So let's measure the location of this one here and there. Okay, so you can move that one to that side. So let's add another balloon and remove that one to make it aligned on that side. Now let's add a balloon, which is a nozzle type balloon, to those, like that. And to add the location of the nozzle, just like that. And for saddles, the location like that, the spacing between saddles. That's the datum line. Let's move this elevation at below here. Let's add the datum line for those nozzles for the boot, and let's add the nozzle tag for the boot. That's the boot, and by using the add balloon, you can select this nozzle to add the balloon of this nozzle here to this nozzle, and by using the balloon item number, you can select the balloons like that. By the way, you can add separate drawings for, you can add projection for that, the total pipe length and the cap height, like that, the projection of the cap from the vessel center line, like that, and the projection of this elbow from here. We defined it to be 300 millimeters. Let's add a tan line of this cap, adding another tan line here for this standard cap. So from here you will complete the information in your drawing, like adding annotations, adding dimensions. If you would like to hide this origin point by selecting any dimension and hide the origin point, so the origin point will be hidden, or if you would like to make it visible like that. We can make some sketches over the view, like by selecting the view, and from place view you can select create a sketch, and let's add some information here, like circumference building line 1. Okay, and let's rotate it like that. Rotate it on the counterclockwise, and let's take a copy from that one as a circumference welding line 2. Okay, let's take another copy to the bottom cap here and rotate it counterclockwise. And that's circumference welding line 3. Let's add definition for the datum line. Here's that datum line. So a lot of information you can add it to your drawing suits your requirements, and it depends on your needs in your drawing. Some other options we will talk about it, like now we will make an opening for a nozzle, like this on shell, and for the nozzles created on the unreal element, like those elements we created a connection point. It's not a real element. Okay, we add those nozzles over this element. So how we can make an opening for those elements on the nozzle, and how we can create an opening for the other nozzles. So from here we have this assembly, and let's open the nozzle opening for, and let's load the nozzles. Here we have, so after opening this for, you will click on load to load the nozzles on the project. So we have a boot nozzle N4, N3A, N3B, N1. Okay, N3A and N3B, they are located on a child or unreal element, which is the connection point. So right now let's remove them from the list, and for the other elements we will make a cut for those nozzles with a clearance with 2 millimeters around the outside diameter of the nozzle, and we will apply that on all elements. And let's click on extrude process. Now we will create a cut for this hub on the shell, and for the boot on the shell, and for the nozzle on the bottom head. Now you can figure if we get a cut on that nozzle on the shell. So if we open the shell, for example, you can figure that we have a cut for the nozzle and a cut for the boot, and the same for the bottom cap. If we open this cap, you will find that we have a cut here on this nozzle. Regarding nozzles created on unreal elements, we will need to make this cut manually. Okay, because currently SEG will read the main elements, which is the can one in that case, or a bottom cap in that case, or a can one in that case. But here we haven't a real element to make a cut on it. So in that case, we will need to make a cut on the main element, which is this nozzle. So we will double click on this one, and from the sketch tab, we will select create a sketch and select the facing of. So it's double click to go to the level of the nozzle, and let's create sketch here. And sorry. So from here, let's select the outside, make a projection for the outside diameter of the nozzle. Okay, and let's make an offset to make a cut clearance with 2 millimeters and convert those two lines to construction lines. Now we will make a tab with 2 millimeters for both nozzles. Now we can make a cut with a negative value up to, so let's select 2 and select the inside diameter of the vessel. So let's select the profile and click on OK. Now we make a cut on the nozzle like that for those nozzles, and we can make this plane invisible. So we make a cut for this nozzle like that, and let's click on save. Okay, now if we come back to the drawing, you automatically will figure that you get that update here. You get the cut clearance. So if we measure this clearance here, that's 2 millimeters, that's which we defined on the drawing. The same for this one. We have this cut here as a clearance of the cut for the nozzle. Okay, now let's discuss one more thing, which is if we have on the next revision an update for like adding another nozzle and changing the location of this nozzle, which takes a cut. Here we already make a cut. So how we can update this cut for this nozzle and adding another nozzle, and how we can reflect that to the bill of material and the nozzle table. Because we will get a new items, so how we can reflect it inside the drawing. So let's come back to the model, and for the end cap, let's add a nozzle. Let's add N2, and this nozzle we will make it let's say 12 inches nozzle with a scalable 60. Let's add a rebad. Let's add the thickness. The offset of this nozzle from the center line to be 0. Let's name this nozzle as outlet. Let's click on save. Let's add a flange to this nozzle. So let's add a standard flange into flange. So select the face, rating 12 and 60. Click on save. Now when we come back to the nozzle, we can define the projection of this nozzle. So let's make it 50 millimeters, so we can calculate the projection of this nozzle. So SEG will draw that and calculate the projection of the nozzle, the pipe projection. So let's click accept, so you can figure that the value will be changed here. Now we can define the weld values for this nozzle. So now we add this nozzle on the top head, and we will modify the location for nozzle N1. So for N1, we will come here and make the location to be 400 millimeters. So the tailing lug, to avoid the tailing lug, so we can make it on 800 millimeters. So let's make it on 800 millimeters and click on save. Now when we click on start assembly, first thing, the location of the first nozzle will be modified, but the cut still in the same location. So how we can deal with that? That's the first point. The second point, here we have a new nozzle with a new bill of material. So the bill of material will change. So we have two new items, the rebad and this pipe, 3 items by the way, not 2. 3 items, the rebad, the pipe, and the flange. So how we can reflect that on the bill of material? I think I need to change the value of this rebad. Okay, now we have this cut on the shell, how to delete it and how to create a new one. Okay, so from SEG, let's open the opening form and let's load the nozzles. Let's remove all of them and select N1 only, which is this one, okay, which is located on CAN 1. Okay, and we need to delete this nozzle. Delete the cut of this nozzle. So after selecting it, we will click on delete, not delete external data on the project information. I will let you know the difference between them, but here we will click on delete. So delete will delete the feature here. You can figure that you deleted the feature of the cutting here. So let's close that and reload the form again and remove all nozzles and create a cut for nozzle N1, the new location, by making a clearance with 2 millimeters. And let's click on extrude to make a cut for this nozzle again on the shell with the correct position. Okay. You will find on our channel a detailed video discuss the option of the nozzle cutting. Here that video, which is answering webinar questions part 1. In this video we discuss in detail the options of nozzle cutting and how we can deal with it. Okay, now we get those new items, and let's add some other new items like adding stud bolts to this flange, adding manway davit to this blind flange. So how we can do that and how we can reflect all of that to the drawing. Here let's come back to the desktop and let's open the Trouvé, and for the flanges let's add the bolted materials. Here for the 24 inches, here that's the length of the stud bolt and that's the size in the UNC. So let's add a stud bolt here to this cover. So from here let's select the cover, and from elements let's add a stud. Okay, and for this stud let's select UNC and select the size, which is 1.1.5. Yes, it's 1.5, and the length is 230, and the gap between bolts or nuts, which is the total thickness of the flanges from here to there, that's the value. So let's take it, copy and paste here and save this value. So let's add a stud bolt, and from here let's add a hand grip. In that case, let's add that type of hand grip, which is welded to the outside surface of the flange. Let's define the length with the orientation of this one, and let's click on save. Okay, the offset of this flange, let's make it on the middle of the flange. So let's measure the thickness of this cover. So the thickness is 68. So let's make it on half of that, 34. And let's click on save. Now when we click on start assembly, now we have the stud bolts. Okay, now we have this hand grip and the stud bolts. Let's add a detailed davit. So from here, let's select the cover, and from elements, let's add a detailed davit. So here, let's select this davit, and you will find different types of standards. So let's select this type of davit and select the rating of the flange, select the size and make the direction to the other side, and let's click on save, and now click start simply to start creating the detailed David according to this spec. So you can figure that each element on this David will be created and assembled automatically. Now we have the David assembly here, the stud bolts and the hand grip. Now we would like to reflect all of those changes to the bill of material inside the drawing. As you can figure, the drawing will be updated. Here, let's delete that was the clearance distance. Here, that's the manhole location, changed automatically. The cutting option reflected to the drawing. The new nozzle will appear here, but we need to update the scale, update the bill of material, and update the nozzle table. So how we can do that? If we come back to SEG here and click on drawing, let's click on create drawing, and let's minimize the scale a little bit first. And from tables, let's remove all of those checkboxes. We will find here an option for update tables automatically. Okay, this checkbox is not selected. If we select it, that means any selected table here will be updated. Like, we need to update the bill of material table and we need to update the nozzle table. In case of selecting this button, let's check what's happening when we click on create button. After changing the scale, take a look to the bill of material. Now the bill of material will be refilled again. Here the nozzle table will be refilled again, takes place. Here for the bill of material, because the content is changed, we can move it a little bit up like that by hand. So now you can figure that we get those items, but if you get the balance of the item number, you will get it empty for the new items, because you will need to update the item number. So like when you select the stud bolt, and let's add another balloon for the nuts, you can figure that the same for this nozzle, by the way. If you select the item number for that nozzle or that flange, you will find the balloons are empty. So we need to make an update item number here from the balloon row, because the item number in the bill of material is changed. Okay, so you can figure that the bill of material for both equipments calculated automatically in detail including the weights of each element. So here that is the correct weight of the element, the real weight of the element. Now after modifying that and the bill of material, you can figure that now we have nozzle N2, and here that's the projection and welding style for this nozzle. Okay, if we measure the projection of this nozzle from here to the facing, it's 500 millimeters as we defined. Okay, now I think we cover all points. We mentioned it on this part of the training, like discussing the user interface of the SEG, the available modules, creating a new project, the difference between main element and child, the UCS concept, and the unreal elements and how we can use it, and some of common mistakes that user can make it during the modification. One of the common mistakes, which is element stuck in the memory. That takes place in some cases, like changing the type of the nozzle. Sometimes that may cause a problem in Autodesk Inventor, which is deleting a completely feature and defining a new one. So let's try this, and I hope that takes place to show you how we can deal with that. After that, we can open the discussion if you have any questions. So in N2, let's select long weld neck head nozzle, and let's define the rating, make the size as 6 inches, make it 0, and calculate the projection. Okay. 500. Wait. Click on save. Now let's click on assembly. Now we change the type of the nozzle. The first type was a nozzle from pipe with reinforced band. Now we have a long weld neck nozzle. Okay. So I will close the project and open it to check if we have a problem or not. Now we need to delete the flange. This flange, we need to delete this one. Okay, so let's come back here, and for this nozzle, let's delete the connected flange because we have a long weld neck flange and no need to add another flange. So after deleting this, we have the flange here. So now let's close this project, and after that we will close Autodesk Inventor and SEG and reopen them again to check if we have a problem with this nozzle or not after changing the type of this nozzle, and if we have an issue, how we can deal with it. Okay, now we will close both of Autodesk Inventor and SEG, and be sure that no other instances from Autodesk Inventor is opening. So let's take a look on the end task menu. No other instances from Autodesk are running. We have a one here. Okay, so you can figure that nothing on the task bar. But here we have an instance from Autodesk Inventor, so we need to be sure that all instances are closed. Now we will open SEG. Okay, now let's open the project. Let's go to the desktop and open the demo of today. And let's open the assembly. Okay, here this issue doesn't takes place, but sometimes you may find after changing the type of the element, you will find it missed on the 3D model. But in that case, it's come in the right way. But sometimes that's because Autodesk Inventor sometimes some elements stuck on the memory, so you will need to close Autodesk Inventor and SEG to release that. After that, you can modify that element. How you can modify it if you find it deleted here or not appear, you will come back to SEG, and from the tree you will select the element from the tree, and from Edit tab you will click on Reset Inventor Item. This option will recreate this element again in case of missing. Okay, let's open the drawing. Another way to open the drawing by right clicking on here, and from drawing you can open the drawing. So the drawing will be opened here on Autodesk Inventor. And regarding changing the nozzle type, the projection here will be recalculated again, like that. Okay, now from here, let's make an open discussion regarding to this training. If you have any questions regarding to the two samples that we create, the first one, which is this nozzle, and how we deal with creating the main elements and the childs on the main elements, how we can make a connection point to add a nozzles on another nozzle, how we can make a piping, like adding a T, elbows, all of that, how we make a nozzle cut, how we make a davit and stud bolts, how we can reflect that to the drawing. Another sample which is we discussed how we can make the double wall, or how we can make a vessel by using the technique of overlap to make difficult configurations like that. So any questions regarding the previous part of 3D modeling and detailing? Hello?
Hello sir, Nirupal here. Sir, for the modular seal, the same overlap overlap technique we can use for creating the pad plates for the inner support plates, no?
I don't get your point. Would you mind to raise your voice a little bit?
Hello, can you hear me now?
Okay.
We will be needing pad plates for the inner support plates of molecular seal. So same can be done by using overlap technique, right?
What is the inner support place in this drawing? Would you mind to guide me?
Yeah, hello. These supports between the inner shell and this inner pipe. This support we created, na? Plate support. Inner plate we added, na? For that we want RF pad.
Okay. Fauzan, would you mind to give him the Satish the ability to share his screen to show me what he is talking about?
Yeah, sure, Ahmed. Just a minute.
Okay.
Satish, you can share your screen now and explain.
Wait a minute, I will just open the drawing. खूप जुनं आहे सर्व्हरवर असेल ना आपल्याकडं तो मेल जुना आहे खूप कॉमन वर आहे का एखादा
हफ्ते के अंदर नहीं हो रहा है तो मेरा पूरा डेटा उसी पे था
Okay, can you see my screen? Hello?
Yes, I'm seeing.
Yeah. This supports na.
What is the configuration of this support? Would you mind to show me a detail for this one? Because it's not clear here on the general arrangement.
Here there is a gap and we want pad for this plate support. Right now we have created the inner plate, but we did not created the pad.
Okay, this configuration as it is as a one piece, it's not available, but you can do it in SEG by that way. I will flip my screen to show you how to can do it. Dear Fauzan,
Yes.
would you mind to give me the ability to show Satish how he can do that?
Yeah, Ahmed, you are organizer now, so you can share your screen.
Okay. Bismillah. Here, as we discuss, when we make a half section on this visit, we make this option to make this long blade, and I think it's apart from this one, which is we have a part here, but as I can see, the drawing is not here. But as I can see from your side, we have a wear plate here and another wear plate here, and we have a stiffening ring here. So to add a wear plate here on the shell side, we can do that by different ways. Okay, we discussed about making the unreal elements, so we can make unreal element to add array pads with a certain location here, or by making, if we open the that element which is shell 2, so if we select shell 2 from here and from elements, if we open the internal attachments, we can find that internal rebad. So from here, let's add a rebad here for this one, and from here you can define the length puts of this rebad. So let's make it 1 meter, for example, and the width 100 millimeters, the thickness, fillet, and the location that we need 0 degree. Okay, so let's check the values here. So we can decrease that one with 3 millimeters, and let's make it 1 as single one. Okay, and let's make the assembly to show you how you can make a part of this support on one side and another part on the other side. And if you would like to include an item like that in SEG library, you can arise your request to our technical support team to add the required elements in SEG library to give you the ability to add to use it anytime after that. Here, if we let's take a half section from here, but let's flip the section, and let's move that one a little bit. It's on 0 degree. Sorry, where is the reband? Yes, it's here. Sorry. So we have this reband here. Okay, so let's take a half section like that, but we need to adjust the locations. So let's come back. You can figure that we have this rebad and we need to move it a little bit. So let's measure the required distance. We need to minimize the location of this rebad. And let's click on the assembly. So we have this rebad. If we take another section from another view, like that view, if we take a look from the top view, you can figure that we get that. Okay, so you can make it by different ways, but in case of needing it as a special part with a special form to define it in SEG, you can raise up your request and we can add an item like that in SEG library. Okay, any other questions?
Yes. For saddle supported vessels, na, I didn't find any option for earthing lug, saddle earthing lug. Hello.
I cannot understand about what you are talking about.
Uh,
For what?
we we provide earthing lug on the saddles, na.
Rectangular vessel?
Uh, Rectangular earthing lug on the saddle, not
Would you
earthing
mind to
board.
share your screen?
Mm, Wait a minute, I will just,
I will stop sharing.
yeah. क्या तो है?
अपना भी होगा ना ड्राइंग इसके अंदर
ये ना ऐसे टाइम पे वो रखना चाहिए फॉर्म में भी।
अरे वो भी अपना ही सिस्टम चाहिए था.
कॉमन कनेक्ट होत नाही का?
कॉमन वर आहे का एखादं? कॉमन आहे?
नाही नाही कॉमन वर
तुमच्या कॉमन वर आहे एखादं?
नाही.
सत्य केस में देगा सत्य केस में मोबाइल एक्सचेंज है
अरे किधर ढूंढेंगे?
सैटरडे को बैकअप सब पूरा है नहीं इसलिए नहीं है हमारे पास.
कौन से सब जीए ड्राइंग्स ही है?
जी ड्राइंग में थोड़ी होगा.
क्या कर सकते हैं नहीं इसमें नहीं ये में नहीं
सैडल डिटेल सैडल पे होगा ना?
लेकिन लाइसेंस नहीं मिलेगा अपने को
हेलो फौजान. Fauzan?
Yes, Satish. Yes, Satish.
Yeah, I can't share my screen actually.
Yeah.
Share option is not accessible to me. Yeah, okay,
Yeah, now
thank you. Okay, can you see my screen?
Yes.
So here you can see the earthing lug, na?
Yes, the grounding lug or earthing lug.
Yeah.
Okay. Any other question before flipping the screen?
There are, but okay, we will discuss it later. Actually, we have some points related to detail drawing, how to
Okay,
create
so
different sheets.
now I
Okay.
flipped the screen. Now let's add an earthing lug here to this vessel. Actually, as we discussed, the child, you cannot add an element to a child. So how we can deal with this on the assembly? Now let's select the shell, okay, which is can1 in that case. And from here, let's add a grounding lug. So from external attachments, let's add a grounding lug. And from the grounding lug, let's select this type. Okay, keep the dimensions as a default and click Save. Now let's click on the Yes simply. Now we will get this slug, but it will be connected to the shell. Now we will make a trick to move it from the shell to the saddle. Okay, now we have this slug here. Okay, it's here. So you will get it on the tree like that. Let's delete those constraints here. So now this slug will be free. We can move it anywhere. Now let's add a constraint. Let's add a constraint for this one by making this surface mate to this surface and make those are flushed. After that, make that face far from that one with 300 millimeters like that. Now we have this grounding lug on the saddle. If you come back to the drawing, you will find it on the drawing like that. Okay, I hope that that's clear. But after adding this element, we delete the default constraints which make it assembled to the shell. After that, we will assemble it to the saddle. Okay, one more point I would like to discuss it regarding to this. If you make a modification to the shell itself, like changing the inside diameter, changing the length, okay, like that. Let's save that. Okay, and from okay, let's decrease the length a little bit. Okay, and let's click the assembly. Sometimes when you change the type of this shell, the grounding lug will need to be reassembled again, and you will find a new constraints will appear like that. I will show you that, but I will make it by hand like that. Except you will find those constraints appear like that, and you will get an error on the constraints. In that case, you will need to delete the last three constraints which created from SEG again to keep the earthing lug on the right location. Okay, any other questions?
Okay, yes. We want separate sheet for nozzle details and bill of material. Can we do that?
Yes, sure. You have different ways to do that. If you would like to make it by hand and add the details by hand, you can do that. And if you would like to make a detail for each nozzle, you can do that from SEG software. Let's do it by one of those ways. We have the general arrangement drawing, and let's create a new sheet like that. Or if you would like to open a new drawing, you can do that. But let's create a new sheet to add a detailing for nozzles. Here, let's add a detail for this vessel, like that, and define the scale to be 1 to 4, for example. And let's move it outside here. So we need to make a detail for this nozzle. So if you would like to make let's say a section like that for this nozzle, so you can get a detail for this nozzle like that, and you can define if you would like to make the hidden lines visible by that way, to get the highest point of the shell, to measure the let's say the hub height. Okay. So from here, let's make a sketch and project this line. Okay, so we have this point here. So if you would like to measure the hub height, you can measure it like that, and let's make this one invisible. The total hub of the height, like that, from here to there. The bevel height, the straight edge here, the inside diameter of this hub, the hub thickness. So you can make a detail like that. The same thing we can do it for the hub. If we, let's say, take a section here by the same way, let's take a section like that, and you can figure that we have a saddle appear on that drawing, an elbow. So if you would like to remove all of that, we can do that by many different ways. By selecting the view from the tree here, like find the browser, and from here you will have the assembly, and you can hide the saddle. So we have here, if we extend this one a little bit, you will find the right saddle here. You can make it invisible, so you make this saddle invisible. If you would like to make the trunnions invisible by the same way, so they will be invisible. The nozzle in the tool, which is on the top head, so you will get this detail like that, and you can define. If you have a forged hub, for example, you can define that the end thickness of this pipe, the projection of the long weld neck nozzle to the end of this one, the total length, like that. All of that you can define it here. The same for the hub height itself. If you would like to make the visible lines appear and you would like to measure from here to there, so that's the height, and that's the maximum height, the inside diameter. So by that way you can make a detail for a nozzle on SEG by an easy way. And you can break here. If you would like to move this view up and down, you will not be able, so you will need to break view. So from aligned you can break the view, and now you can move the view anywhere on the drawing. Here the same way for this view, you will need to make a break, so you can move it, select on break, and now you can move it anywhere on the drawing like that. Okay, any other questions?
Yes, actually, as per our practice now, we create a different bill of materials on every sheet. Suppose on GA drawing, we start the numbering from 101, and in nozzle detail drawing, we start the numbering from 201. So can we do that?
As mentioned on the SEG bill of material, it's a standard format. The numbering, you can deal with it in two different ways, which is make it on the first format, which is sorting from 1 up to higher numbers, like 1, 2, 3, 4, like that. Or the second way of sorting, which is SEG numbering. Okay, that way will give you sorting in that format, which is 1.1, 1.2. Regarding the formed heads, it takes grade number 1. So if you have more than one of formed heads, it will get 1.1, 1.2, like that. We have to formed heads. For shells or rolled blades, like cone or shell, it takes a grade number 2. So you can figure that the centric cone takes 2.1, shell course takes 2.2, shell course takes 2.3, like that. For the fitting, it takes a grade number 3. So you will get, for the standard caps, you will get a grade number 3. Seamless pipe, all of that, you will get, with a different grade, you will get a number based on the grade. That's the second way of numbering in SEG. Those are the available types of numbering. if you would like to make another numbering, in that case you will need to make that by hand, and I will show you how you can do that. From here, from the bill of material, you can export it in Excel format. After exporting it in Excel, like let's export that to the desktop. Yeah. Okay. Okay, now it's exported. If we open it, sorry, that's it. If we open it from the desktop, let's delete this row because it's including the part number. Here we have this list. Okay, so this list for the two equipments, not one only. But by the way, if you would like to modify or edit or add any element, modify the description of the element, you can double click and edit. After making your modification, you can import that to the tables. So from here, the values start from A3 and the heading start from A2. So if you would like to import a table, so from general tables, we can import a table. And from here, let's select it from the desktop. So let's select the BOM here.
But I think by this way we need to renumber ballooning also, na?
The balloons, yes, you will need to arrange the balloons numbering again.
Manually.
Okay, so I'm telling you that it's better to keep everything from SEG, to keep all information synchronized. Any change here, it will be reflected there. So no need to hand modification. Okay, so the start data cell starts from A3 and the column header from cell 2. Now you will be able to import that external table. Okay, and you can change it to include it as the bill of material table. Okay, that's it, and you can control the width, length of each one. You can move it, drag and drop anywhere in your drawing. By that way, you can, after modifying the Excel sheet, you can import it and modify the location of the drawing inside your drawing. Okay, that's the way if you would like to make it by hand. Okay, any other questions?
Yes, actually, one more thing.
Yeah.
I want to do orientation degrees for the nozzle. So I didn't find any option for that.
Okay, it's as mentioned, it's appeared on the nozzle table. Here you have an orientation table. So each nozzle you will get the orientation on the nozzle table, and if you would like to show it as a separate, from the tables you will open nozzle orientation and you can get it like that, and you can export it on a separate Excel sheet. Okay, if we open this Excel sheet here, where I put it, it's not on the desktop, sorry. Okay, or you can take a copy from this table, like that copy. After exporting the Excel sheet, you can import it by the same way that we did here, or you can remove those tables, like the OD, you can remove it keep those. So we will remove all of those and keep the orientation and tag. So you will get this table, which includes the service, size, and orientation of each node. Okay, I hope that I answered your question.
Okay. Okay. Then for shell, can we get the cut length of plate?
Get what?
Cut lengths of the plates for shell. If we create from multiple sections, we create from multiple plates, we create shell. Suppose my vessel diameter is 7 meters. So in that case, I need to make a shell from 2 plates. So can I get the shell plate lengths in BOM?
Okay, as we discussed that during the session, but no problem to repeat it again. Here, let's create a new vessel. Okay. This vessel here, which is SD100, let's add a shell course. Okay. This shell course, let's make it as a shell from different pieces here. And as a default value here, you can figure that it's 7 meters. But before this step, let's select the vessel itself, and from the equipment setting, let's define the position of the vessel and define the available plate dimensions. Let's make the available plate length is 8 meters. Okay, so that's the available plate length. So that will be used to calculate the required number of plates on the shell. So let's click on save, and from here let's click on the shell. And before selecting it, let's calculate the arc length of this shell. Here let's define the inside diameter. So let's say the thickness of this shell is 20 millimeters. Okay, so the diameter of this vessel, the mid diameter, will be like that. Okay, so when we let's define any value here for the arc length, you can figure that the circumference length here is 22 meters 0.53. Okay, that's the chord length of the shell. That's to get a value before calculating. So in that case, you have a plate length with 8 meters. So if we divide this value, which is 0.3 by 100, you will need 3 pieces of shell. Okay, 2.7, that means you will need 3 pieces. Okay, now let's select this shell. Okay, and from here, let's select shell from different pieces. Okay, and here SEG will inform you that the delivered plate length is 8 meters. Okay, so let's accept this, and from here let's calculate that. So the first shell course will be 6 meters. Okay, and the start angle will be at 0, and recalculate that. Automatically SEG will inform you the last piece, when calculated, the length of it is more than the available plate length. If you take a look here, it's more than 8 meters. It's 8 meters and 28 millimeters. Okay, so we need to increase this value a little bit. So let's make it 6 meters point half, and click on update. Now SEG calculated the last piece length automatically, which is the you have the first blade here with 6 meters point 5, the second blade with 8 meters, the third blade will be calculated automatically based on the chord length and the sheet 1 and sheet 2. Okay, now let's click on save and start creating the assembly for this shell. As you can figure, this shell will be created from different pieces. That's the first piece, here the second piece, and here the third piece. Now if you open the first part of this shell, still updating. seconds here. Okay, we have this shell. It's included from 3 parts. Let's open the first part. Okay, and get the flat pattern for this part. If you measure the length of this one, so from inspect tool, we will measure that length. You can figure that it's 6 meters 0.5, which is the same value defined it here. Okay, so let's open the second piece from here. So let's open that one. Sorry, let's create the flat pattern. If we measure the length, it's 8 meters as we defined it here on SEG. It's 8 meters. Okay, the third one, we close this one. So let's open the third one. Open. We get the flat pattern and measure the value. So from inspect, let's measure the length. Now we have that length, which is 7528. It's 7528.847, the same value which is appear here. So by that way, you can define the shell from different pieces. That's usually used on large vessel diameters or in storage tanks. And I could show you a sample created by that way. So if we come back here to the stop icons, vacuum tower. Okay, if we open that column here. Okay, it's created on a higher version of Autodesk Inventor, no problem. I could find another copy of that one. Yes, it's the same, created on a higher version, created on 2022 version. Okay, no problem. But here, I would like to show you that here in that shell course, we have a nozzle, a heli-side nozzle, and that nozzle needs a shell plate with a different thickness. Okay, so how we can do that on SEG? And the same for this nozzle. Need a shell with a different thickness. Yeah. So how we can do that in SEG? There is an element give you this ability. If we add another shell, which is shell 6, which is shell from different pieces and the thicknesses. Okay, if we defined the diameter of this one as 9 meters, for example, okay, and the main course thickness is 10 millimeters, and let's define that as 4 pieces. The length of the first course is 8 meters, and here let's upgrade the thicknesses. That course we will make it from 20 millimeters. That one will be 14, and that one will be 10. So let's click on save and update. Now let's click on assembly to start creating this shell from different thicknesses. So if we make a zoom and measure the thickness for each plate, from the inspect tab, if we measure the thickness here, it's 14 millimeters. If we measure the thickness for that one, it's 20 millimeters. If we measure the thickness of that one, it will be, measure the thickness, it will be 10 millimeters. So you can make a shell with different thicknesses like that by using SEG software. Okay, any other questions?
Okay, I tried one sample hemispherical head with a petal type of construction, multi-piece construction. Hello?
Would you mind to say that again and slowly, please?
Yeah, uh, by using SEG, I created a hemispherical head in a multi-piece, means crown and petal construction.
Yes.
But can I get the what development of each petal?
Okay. As you know, to get shell development or blade development for a part, it should be rolled in one direction by the ruler. Okay, not in two direction, because two direction that needs يعني, another way for fabrication, which is not rolling. You know what I mean?
Okay. Yeah, we do it by
Cones
tracing.
and the shell, you can get a shell development for it because the rolling is around one axe, not in two axes, not in space like head. Because the heads they are formed, you need hydraulic jack, or there are many different ways for fabrication. So to get the shell development on Autodesk Inventor, it's not available. But I will show you a way to get it, but it's not completely correct. Like here we have this ellipsoidal head. Okay, in Autodesk Inventor there is a tool called Unwarp. Okay, this Unwarp tool give you the ability to uh, stretch or get the flat surface of this element. That's not depends on the thickness, and actually you know that the thickness is a very important factor on forming. So here you can figure that Autodesk Inventor calculate the required diameter of the blade which needed to get this surface after forming. Okay, but actually from my side I don't suggest using this way to get the flat pattern of items. If you would like to use it, you can do that, and that's a way some people are using it. But actually I don't recommend that way because it's not taking the thickness in as a factor in the calculation. I hope this point is clear.
Yeah,
So when you click on OK, you will get a surface. So from this surface, you can measure the diameter of this surface, and you can use it as a raw material for the head to start fabrication from that value.
अजून काय आहे?
Okay. Any other questions?
पुढचे 9:30 सांगा टाइम.
Okay. Yeah, actually we are
नाही
काय?
बिल ऑफ मटेरियलसाठी ऑटो बोलवली.
Okay. Auto loading करू शकतो. There is a one more question. Actually, we are creating different sheets. Suppose for Manway and its David, we create a separate detail sheet, and I want BOM for only that items. Can we do that? Hello.
Again, please.
Yeah, I want a separate detail sheet for Manway assembly and David, and for that I want its BOM on that sheet only. So can I do that? Means
Yes. Yes.
do not
Okay.
duplicate.
Yes, I will show you how you can do that for the for that. If we let's say we have let's add a new nozzle here and make a David on it. By using the group option, you can accumulate those items inside a group. Okay, those items you can get them inside a group. After that, you can create a drawing for them. But that will cause some issues here on the general arrangement drawing, because the group should be done before creating the drawing, because you will miss some information from your drawing, like those dimensions, and if you have any annotation you will lose it. So you should make this group before going with making a group. But right now, let's make a group. So from here, from the cover, let's add a group, and from adding a group, let's make David cover. David simply. So this group will include from the cover, start from the cover and end at the body flange. Okay, so let's select body flange and let's select save. Now SEG will start saving that, and if you take a look to the assembly, you will find here those items now come under this sub assembly or this group, which is cover assembly, and you will need to make, as you can figure, the colors changed to blue color. That means the assembly need to be recreated again. Now let's click on start assembly. Okay, let's accept this error. Okay, so let's delete this pattern. And now we have the cover and the stud bolts. Okay, now let's save this and reassemble that again. Okay, so an error like this during the pattern of the bolt, now we need to reset those items, okay, to recreate them again inside this group. So let's select the cover, and from here, from edit, let's reset this item. Okay, and the same for the stud bolt. The same for David. So making the groups, you should planning for it before creating the drawings and 3D model. You should planning which items you would like to make a drawing for it, okay, to make things easy after that. So let's make the simply. Now the updating of each element takes place. Okay, as discussed here, we are facing a problem to include the gasket and the blind flange in this group, and that may takes us to the next step, which making a reset inventor model. So as discussed, we need to make a plan before creating the groups inside the model, and let's make one more try to reset this inventor item here and there.
One more try.
Okay, we still have this issue, so we may need to recreate those elements inside the group by selecting the group and creating another gasket and the body and delete those items from the model. That's a way to solve this issue if you would like to create those items inside the group. So let's add another gasket. Okay, this gasket has a raised face gasket. Let's add a body flange. We have the same name, but that one with a space, that one without space. Okay. Okay, now let's delete this gasket. Delete this body flange. Okay, now we have this one is free because we still SEG will assemble it by using the UCS. And now let's start creating this group. Now the assembly of the group is created. Okay, and when you try to move the shell, it's automatically connected to this David assembly. When you open this assembly like that, you will get that as a one assembly. All items appear here. So if you would like to create a drawing for that one, so let's open it in a separate assembly like that. Here, that's the assembly of the David. If you would like to make a drawing for this assembly, by selecting the David assembly here, which is cover David assembly, and right click on that one, and from drawing, select create drawing, and click select the size of the drawing. So let's select A3. And from here, we will select two views, an elevation view and a back view. And from here, let's define the spacing between them as 3 centimeters. From here, we will select the elevation view to be the back view. So we will use the back view as the elevation view for the equipment. So from here, let's select back to use it as the elevation view. Define the locations. Let's keep it like that right now, and scale 1 to 10. And from here, let's add bill of material. So let's add a bill of material to this one. And from drawing title, let's make this drawing as David build. And the document number, EWG. And for the revision table, okay, issued for review. Let's add some empty rows, and let's click on create drawing. Here we have the detail of the manway on a separate drawing and with a separate bill of material here. And now let's adjust the location of this manway on the drawing, and let's add some a separate details for the items. So from here, let's come back to the cover, and from drawings, let's click on that. So the location, let's make it on 8 and like that, and click on create. So the location of the divid will be like that, and now we have the bill of material. Now let's add some details for the like this hand grip. Now we have this hand grip, so let's come back to the drawing, and from base view, now you get this one. Let's take a look from that side and grip scale 1 to 4, for example. And yes, now let's move this one right here, and if you would like to add some center lines like that, now you can add dimensions to this one. Another one like the eye bolt, for example, if you would like to add some dimensions for the eye bolt or for this rod, if you open this rod, that one, and take a look to this rod from that side. So if you would like to add a detailed drawing for that one as a custom view here, okay, and make it one arm. Okay, so let's add some center lines. If you would like to make it with hidden lines to get the whole location like that, so you can define the value from here to there like that, the length of the rod, the diameter, the chamfer, the pinhole diameter, okay, the location of this one from here to there, something like that, the radius, okay, the thickness. So you can add something like that to the drawing, and you can add other details like add welding. So from here you can add a weld like that. So from here you can add a fill or a butt weld. You can select the suitable welding detail for that. For here, for example, you can make a fillet weld. For the lifting lug, you can make it with groove weld. After that, fillet weld. So you can create a detail for a group, including the bill of material for this group. And you should, as we discussed, you should update item number to reflect the values of the balance inside the values here. Let's select parts only like that. So you will need to reflect the values here. As we discussed, we change the sort arrangement to that value, which is 1.1, 1.2, and instead of making it by that way, which is sort numbering instead of SEG numbering, here you can get it in 1, 2, 3, 4. So you can figure that we calculate the bill of material automatically, and you can reflect that to the drawing by clicking on update item number to reflect the balance on the form. I hope that gives you an idea how you can make a detailed drawing for something like that. Any questions?
No, actually, now most of the concepts are clear, and
Again,
it was a
please.
really good session. And we
Alhamdulillah.
understand new concepts like gap and overlap, shell with different thicknesses, which are really helpful, and also the grouping the item to create a different drawing of a for that particular assembly. Actually, it was a really good session,
Alhamdulillah.
and we are having one more session on Friday, I think. Na?
Yes,
Yes.
inshallah. And in this session, we will discuss one sample from the sended sample, which is a heat exchanger, including expansion joint. And in this session, we will discuss how to make a two bundle arrangement